Good morning, everyone. I request all members and participants to kindly take their seats as we are about to commence the event. Namaskar. A very warm welcome to all the STM dignitaries, distinguished scientists, policymakers, science communicators, educators, researchers, students, members of the media, and all participants present here today.
It is our honor and privilege to welcome you to the Conference on Public Understanding of Quantum Science and Technology, being organized by Gujarat Council on Science and Technology, Department of Science and Technology, Government of Gujarat, jointly with the International Year of Quantum Science and Technology, UNESCO, National Quantum Mission, Government of India, International Science Writers Association, Indian Science Writers Association, Society for Information Science, and Indian Science Communication Society.
This prestigious two-day conference is being conducted on 22nd and 23rd December 2025 here at Gujarat Science City, a center that symbolizes curiosity, innovation, and public engagement with science.
Quantum science represents one of the most profound intellectual revolutions in human history, from redefining our understanding of nature to enabling transformative technologies in communication, computing, cybersecurity, healthcare, and defense. Quantum science is no longer confined to laboratories. It is steadily entering our everyday lives.
Recognizing this global significance, the year 2025 has been declared by the United Nations as the International Year of Quantum Science and Technology, marking 100 years of quantum mechanics.
At the heart of this initiative stands GUJCOST, the state's premier organization for science promotion, which has consistently worked towards demystifying science, strengthening scientific temper, and bridging the gap between laboratories and society.
The theme, Public Understanding of Quantum Science and Technology, reflects a clear and powerful message that quantum science is not only for experts but for citizens, learners, and future innovators. Science communication is not complete without creativity. To set an inspiring tone for the conference, we now invite our performers to present a welcome dance.
वैष्णव जन तो तेने रे कहिए जे पीड़ पराई जाने रे। वैष्णव जन सकड़ लोक मां सहुने वंदे निंदा न करे केनी रे वाचिकाछ मन निश्चल राखे वाचिकाछ मन निश्चल राखे वाचिकाछ मन निश्चल राखे धन धन जननी तेनी वैष्णव जन तो तेने कहीजे पीड़ पराई जान रे समदृष्टि ने तृष्णा त्यागी बुद्धं शरणं गच्छामि धम्मं शरणं गच्छामि संघं शरणं गच्छामि समदृष्टि ने तृष्णा त्यागी समदृष्टि ने तृष्णा त्यागी पर स्त्री जैने मात रे जाति पाति पूछे ना कोई हरि को भजे सो हरि का होई हरि को भजे सो हरि का होई हरि को भजे सो हरि का होई जिह्वा थकी असत्य न बोले सत्यं परम धीमहि सत्यं परम धीमहि सत्यं परम धीमहि सत्यं परम धीमहि जिह्वा थकी असत्य न बोले पर धन नव जाले हाथ रे
Thank you for that beautiful performance. Help me in welcoming our chief guest for the day, Ms. P. Bharti Madam, IAS Secretary, Department of Science and Technology, Government of Gujarat. Now let us move into our inaugural session by lighting the lamp of knowledge and wisdom. May I request all the dignitaries, as I announce their name, to kindly come forward for the lamp lighting. Ms. P. Bharti, IAS Secretary, DST, Government of Gujarat. Professor Dr. Anil Bharadwaj, Director, Physical Research Laboratory, Ahmedabad. Dr. Narottam Sahu, Advisor, GUJCOST. Dr. Manoj Kumar Pataria, President, Society for Information Science. Professor N.T. Lan, Vietnam Institute of Science Information, Hanoi. Professor Anjana Singh, Nepal Academy of Science and Technology, Kathmandu. Professor M. Sai Baba, National Institute of Advanced Studies, Bangalore. Dr. Viresh Parekh, General Manager, Gujarat Science City. Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST. I request all the dignitaries to kindly do the Deep Prajwalan.
Spirit of respect and gratitude that defines our hospitality. Today, as we begin this momentous occasion, we warmly welcome our dignitaries to the dais. Now, may I request all the dignitaries for the floral welcome. May I invite Dr. Narottam Sahu, Advisor, Gujarat Council on Science and Technology, to present a floral tribute to Ms. P. Bharti Madam, IAS Secretary, DST, Government of Gujarat. Thank you, sir. Next, I request Dr. Narottam Sahu, Advisor, Gujarat Council on Science and Technology, to welcome Professor Dr. Anil Bharadwaj, Director, Physical Research Laboratory, Ahmedabad. Thank you, sir.
I now invite Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST, to offer a floral tribute to Dr. Manoj Kumar Pataria, President, Society for Information Science. Thank you, ma'am. I request Ms. Zeel Patel, Project Scientist, GUJCOST, to welcome Professor N.T. Lan, Vietnam Institute of Science Information, Hanoi, with a floral gesture.
Thank you, ma'am. I request Ms. Masuma Hakim, Project Scientist, GUJCOST, to kindly step forward and present a floral token of respect to Professor Anjana Singh, Nepal Academy of Science and Technology, Kathmandu.
I invite Mr. Pawit Shah, Scientific Officer, GUJCOST, to offer a floral tribute to Professor M. Sai Baba, National Institute of Advanced Studies, Bangalore.
Thank you, sir. We invite Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST, to offer a floral tribute to Dr. Narottam Sahu, Advisor, GUJCOST. I also request Poonam ma'am to please offer a floral tribute to Dr. Vrajesh Parekh, General Manager, Gujarat Council of Science City. Thank you, ma'am. I now invite Ms. Stuti, Communication Manager, RSC Bhavnagar, to offer a floral tribute to Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST. Thank you, ma'am. I sincerely thank everyone for the warm welcome extended to our dignitaries.
To formally welcome the gathering and set the context of the conference, we now invite Dr. Narottam Sahu, Advisor, GUJCOST, to deliver the welcome address.
Good morning, everybody. Today is a very auspicious day for Gujarat, India, and the entire science fraternity of our country. Respected chief guest of this 2 days Science Communication Conference on Public Understanding of Quantum Science and Technology, Madam P. Bharti, Secretary, Department of Science and Technology, Government of Gujarat. Our guest of honor, Dr. Professor Anil Bharadwaj, Director, Physical Research Laboratory, Department of Space, Government of India, Ahmedabad. Dr. Manoj Kumar Pataria, President, Society for Information Science and India and International Science Writers Communication, Indian Science Communication Society, New Delhi. All the dignitaries and guests and invited speakers and our all the pioneer scientists, researchers, young researchers of Gujarat and entire country who are here in this sprawling campus of Gujarat Science City to celebrate and to inspire our next generation learners about the quantum science and technology, which is being celebrated as a tribute to our great scientists and pioneers who have coined this word and started their journey to this new generation on this quantum world. So today, as the United Nations has already been celebrating this year, and we are at the end of this year 2025, GUJCOST as a proud academic partner of United Agency is organizing this 2 days program in collaboration with the IOIQ 2025, UNESCO, National Quantum Mission, Government of India, International and National Science Writers Association, Society for Information Science, Indian Science Communication Society, Gujarat Science City, and our Department of Education and Technical Education, Government of Gujarat. We are proud to welcome all of you. We are proud to start the beginning of this new journey of a new generation with a speed and scale. As Honorable Prime Minister is already giving that clarion call that how our state and our nations and our society and our every citizen has to be empowered with the science, technology and innovation, and to take a very definite role in the Viksit Bharat mission. So as a part of this thing, we have celebrating this quantum science and technology, which has unlimited potential in terms of our concept and our understanding. It has to taking us into a new different era in which we have to be excited that whatever the challenges, whatever the problems, whatever the difficulties we are facing day-to-day life, all have a definite answer in this quantum age. We are starting this quantum age excitement with our secondary and higher secondary schools, college, university department and professors. In fact, we are so happy that our state government, our Department of Science and Technology, under the mission of our visionary secretary, Mrs. P. Bharti ma'am, the department is also planning to taking this quantum science and technology as a thrust area in our upcoming science, technology and innovation mission. In addition to that, with the support of National Quantum Mission, Government of India, we are also establishing some quantum labs for our undergraduate institutions in the institution. In addition to that, we will be discussing that how quantum is going to take a change maker in terms of our content and in the curriculum of the primary to secondary to higher secondary school, college students and researchers. So we are dealing with three aspects of this program. One is hardcore quantum science understanding research, on which we have the pioneer scientists and institutions like Professor Dr. Anil Bharadwaj and the entire team of Physical Research Laboratory and our Space Application Center of ISRO Ahmedabad, who have prepared and given the foundations of quantum communication, which is the major component of this quantum science and technology. We are privileged to have you, sir. We are having this quantum, all entanglement and all the things, very technical things, which has been also taken care of by our mentors, Dr. B. Kamble, sir, who is the former advisor to Government of India, and former director also to the Vigyan Prasar, who is our master person for designing the kit that we are also discussing with you. That kit has been distributed in Gujarati as well as the English language across our schools, every district, along with our state S&T councils, and to also the NQM platforms at the 4 hubs there. So this program is all about the hardcore quantum science research, the communication part, where we have very privileged to have the support and handholding of International Science Writers Association, Indian Science Writers Association, Society for Information Sciences and Technology, and Indian Science Communication Congress Society. So we are very much thankful to Dr. Manoj Pataria, sir, who is the president and who is the former advisor and the director of DST, and also the director of NISCARE, and also the National Science Communications, NCSTC, DST, who has a strong and long association with the science communication, science popularization, and preparing the different modules. So this is the science communication part, and third part is the science, taking quantum science to the society, where we have some sort of case studies that has to be discussed through our panel discussions, and this thing that how our people, those who are now afraid of that cyber frauds or the banking systems or in the developmental security system, how that can be a ease of doing type of business in our next generation society and our peoples and this planet. In addition to that, also quantum, working with traveling from bit to qubit and connecting the people to the planet, to the universe, because with that age-old saying that we all are connected biologically, physically, and this quantum atom-wise also. So in that way, we can say that quantum science is integrating and uniting everybody in our this earth with the people and the planet, so that we'll be entering to a new era where there would be all the challenges would be the new opportunity. Our student has to be work or a dream for a new industry where the concept and the clarity would be totally different, having no doubts of climate change or global warming or something like that. So it's just like a dreaming a new age. So with all these dreams, and to take this fiction to the reality, so we are here for the 2 days to brainstorm how the hardcore research to be communicated and how that benefit has to transfer to the society. So that is the mission and vision of our Viksit Bharat under the Honorable PM, and Viksit Gujarat with Honorable CM, and the mission with the pioneering effort and long-sighted vision of our Department of Science and Technology, and our respected Secretary, Mrs. P. Bharti ma'am. So this 2 days program, having 4 keynote addresses, 2 panels discussions, case studies, the demonstrations, and also to have our science city visit also. It's a 2 days wonderful time. I welcome all our delegates, dignitaries who are also coming from the main, almost all the premier institutions of the Gujarat as well as the other states, all our state S&T council members, and the participants from the Bhutan and 3 other parts of this country. And we are having this one session with the main hardcore scientists from the UK also after this inauguration. So I think all these deliberations that gives a clear-cut context and a concept about this quantum, which would be the next generation tools and techniques for everyone. Whether a scientist or a technocrat or in a common citizens, everybody has to enjoy the flavor and fascination about the quantum science and technology. This 2-day deliberation is not limited to our 200 plus registered participants and delegates. It is also streamlined to all our state S&T council, to all our regional science centers at Patan, Bhavnagar, Bhuj, Rajkot, to all our district science centers, and to all members, those who are not find a way to participate this physically. So this is that ways and means of taking science technology, and when you are working with the quantum science and technology, you can see that whether you are here or you are at a home or this thing, it's just like it will be transforming our perception about that, whether you are how atoms works in a particles and physics. 2 ways we are there. You are at your workplace and you are also here. We are also seeing it all these things. So you will be taking this technology, this science will be giving a multi-dimensional aspect of every aspect that we are thinking. So this is a wonderful session, beautifully, very meticulously curated, and we are looking for the meaningful execution of these things. So we once again thanks and express my sincere gratitude to our respected Secretary ma'am, Mrs. P. Bharti ma'am, our guest of honor, Dr. Anil Bharadwaj sir, our patron and the mentor, Dr. Manoj Pataria sir, and all our delegates, very experienced and very domain experts of this field, both in quantum science technology, quantum communication, and taking also to the schools and the curriculums. So everybody, we express our sincere thanks and gratitude for your support, collaborations and cooperation. We hope that 2 days you will be getting a good time, and the department and the GUJCOST Science City are very keen for your hospitality and your meaningful time here in the Science City. With these words, we once again welcome and looking forward to a very meaningful session. Thank you.
Thank you, sir. We now invite Dr. Manoj Kumar Pataria, President, Society for Information Science, to deliver the opening remarks. Please join me in extending a warm welcome to Dr. Pataria with a big round of applause.
To all, Honorable Secretary of the Department of Science and Technology, Government of Gujarat, Ms. P. Bharati, Honorable Dr. Anil Bharadwaj, Director of Physical Research Laboratory, Ahmedabad, Shri Vimal K. Patel, Gujarat Administrative Services, Executive Director of Gujarat Science City, my friend and colleague, Dr. Narottam Sahu, the key person of this happening place, that is Gujarat Science City, that gives us number of opportunities for meeting all the experts as well as the youngsters, young people, those who are going to take the message of science further to the future. Dr. Nguyen Teng Len from Vietnam, Dr. Anjana Singh from Kathmandu, Nepal. In fact, they belong to a group, international group, that is a kind of intergovernmental organization by the academies, scientific academies, Indian National Science Academy being part of it. We have something like 31 academies all across the world. They belong to that group that is devoted to shared communication, that is science, health, risk, disasters, and environment. All these contribute to the shared communication. I'm very happy to see some of them here. Some of the people are joining online, like Dr. Kanan Purakastya from UK, and he will be talking from the place where this quantum science origin, they have the origin. Our senior colleague and friend, Dr. Sai Baba, who has been always a guiding force for all the science communication activities. In fact, he has led the science communication program at the National Institute of Advanced Studies at IISc campus in Bangalore, of which I am also part of that program. Mr. Shri Prasad Vibha, I am very happy to have him here. He belonged to Vigyan Bharati. Vigyan Bharati is a network of experts and Karkarta who are spreading the light of the message of indigenous science and the scientific thought behind the Indian subcontinent. And Shri Prasad ji is responsible for international program of Viva as well as the western part of this country. Professor R.R. Yadav, we have the former Vice Chancellor from Purvanchal University. He has also been at the Allahabad University. And Dr. Poonam Bhargav, who is again another key person for putting together this wonderful program. So I am very happy to see all of them, and very happy that the youngsters especially have the blessings of all these experts and seniors. It gives me pleasure to share some of my estate thoughts on this occasion. As Dr. Sahu had said, that India has been a leading light in science and technology from the time immemorial. It also reminds me, since we are talking about quantum science and its communication, that we are living in a society, in a world of a lot of uncertainties, unpredictable things are happening, the age of wars, conflicts, a number of things which are happening beyond our control. For that purpose, Heisenberg said at one point of time that if we consider that there is a ship, and ship is loaded with all the amenities, all the facilities, all the technologies, essential and comfortable for the human being. It is going in the ocean. It has all the facilities that human beings require. But nobody knows where the ship has to go. Ship is going with all the facilities. So he said, it is only India's Vedanta that leads the light and shows the way to the world where the ship has to go. So that comes as a kind of solution for all these uncertainties, all these problems, all these issues which are emerging over the period. India also gave another doctrine for resolving issues that is known as scientific temper, or scientific thinking, or scientific thought. It is based on two things. One, the rationality, the analytical mind, as well as the ability to take decisions without any bias, without any prejudice, without any greed, without any pressure. So if we are able to take decisions without all these things, it means we are having a scientific temper. It is another doctrine for resolving the problems. It also emerged from India. And now, this quantum science also gives a kind of way to resolving problems, understanding issues, or leading to the solutions. So it is giving rise, apart from the quantum science and technology that the experts will narrate, it also giving rise to a sense of quantum thinking. So what is quantum thinking? It's a mindset inspired by quantum physics that moves beyond binary, either or, two options. It is beyond these options, giving lot many options. Logic to embrace complexity, interconnectedness, and multiple possibilities, allowing us to hold contradictory ideas simultaneously, see problems from all angles, and navigate uncertainty with greater flexibility and creativity. So that is the kind of sense of quantum thinking that is coming to rescue the mankind. That is not only a science, it also has a social attribute that gives number of solutions. So I'm very happy that we will be discussing in these 2 days on these very important and significant issues, and looking forward for wonderful discussion, especially on quantum science and its communication. Once again, I thank to Gujarat Science City, Government Department of Science and Technology, especially Dr. Narottam Sahu, Secretary Madam, and all their team for putting together this wonderful program. I am also thankful and welcoming all the delegates who have coming from different parts of the country, from India and abroad. And let us have a wonderful discussion, deliberation, and a comfortable stay. Thank you very much. Wish you all the best.
Thank you, sir. It is now our privilege to invite our guest of honor, Professor Dr. Anil Bhardwaj, Director, Physical Research Laboratory, Ahmedabad, to address the gathering. Please join me in extending a warm welcome to Professor Dr. Anil Bhardwaj with a big round of applause.
नमस्कार, सुप्रभात, केम छो, राम राम, राधे राधे, जय श्री कृष्णा, and a very good morning. Dignitaries on the dais, Mrs. P. Bharti, Secretary, Department of Science and Technology, Dr. Manoj Kumar Padaria, President, Society of Information Science, Shri Vimal Patel, Executive Director, Gujarat Science City, Dr. Sai Baba, our colleagues from Vietnam and Nepal, and Dr. Poonam Bhargav, and dignitaries of the dais, science communicator, educators, researchers, and students coming from different parts of the country. I'm extremely pleased to be here with you all at the inauguration of a unique conference called Science Communication Conference on Public Understanding of Quantum Science and Technology. So what you're trying to do is communicating science to public, and that's how the science communication is. It becomes sometimes very difficult to communicate the science to public, and that's why we need a lot of science communicators, and many of them are here in this dais and off the dais. I also congratulate GUJCOST, Department of Science and Technology, Gujarat government, for organizing this conference, a unique conference, and in the year of International Year for Quantum Science and Technology. It is also heartening that many Science Writer Association, that is International Science Writer Association, Indian Science Writer Association, Society for Information Science, and Indian Science Communication Society have joined together with the National Quantum Mission for organizing this conference. I hope you will be hearing this quantum science and technologies throughout these 2 days, and also hearing words like quantum communication, quantum sensing, quantum computers, quantum metallurgy, quantum materials, and so on. These are all buzzwords which are being used now, but they are all quite advanced. And that's why this conference is unique, because you are going to understand in a much simpler language using this science communicators about this all things. Generally, in the case of quantum computers, we use qubits. We also talk about quantum communication, and we talk about quantum key distribution. That is, when you're communicating, not through the conventional ways in which we do currently using radio waves, we use quantum communication where quantum key distribution is the major focus. Physical Science Laboratory in PRL, that is in Ahmedabad, has been working in this area for quite long. And very recently, about a year back, we have recently demonstrated that we can have a quantum communication using QKD over a distance of about 300 meters in space. And that has been demonstrated exceedingly well. And subsequent to that, we also said that how do we communicate between two that is called communicators, and attaching this this communication means with the fiber optics, because we have a very long laying of fiber optics cables, and how do you communicate these two? More importantly, how do you communicate in space using satellites? And that's why we are developing a satellite which will be capable of doing communication from ground to space, and how do we connect this with the fiber optics cables. So we demonstrated that over 200 meters in space, and then fiber optics cable running from Ahmedabad to Delhi, how do we communicate? Using the QKD, because photons what we use are entangled. So entangled photon sources, or you can say single photon sources, are the key for the quantum communication. More recently, you must be also hearing about artificial intelligence and machine learning. And if you combine these two, that is quantum communication, artificial intelligence, machine learning, it becomes a deadly combination which cannot be hacked. And that's why the whole world is looking that can we have a very safe communication so that it cannot be hacked. I'll give you one example of how artificial intelligence is used in space in ISRO. We started this more than 2 decades back, when we are planning to have the Mars orbiter mission. That's the Mangalyaan. And it was the year of 2013 when we had the launch of the Mangalyaan. Now, if you talk about communication from Earth to Mars, the time delay is about 8 minutes to 45 minutes. That means if you say to the Mars orbiter mission, hello, how are you? You have to wait for half an hour for signal to receive back. That means if something happened in the spacecraft, you will not be able to know what has happened. And that's why we developed the artificial intelligence in the spacecraft, or I should say a smart spacecraft, so that it itself decides of its own using the machine learning, which we called as FDI, Fault Isolation Detection and Recovery System. And this was used 2 decades back in space on the Mars orbiter mission. And it was essentially required because the time delay for communication is extremely very, very large. So in this world, when we are talking about quantum communication, which is basically, we say is a hack-proof or a system of communication where we cannot understand what is going on unless until we look into details of that. But it becomes a foolproof system because there are 2 entangled photon sources which are having the communication among themselves which cannot be hacked, and that's why it becomes a foolproof. I should thank the GUJCOST for organizing this lovely conference over 2 days on science communication, for quantum science and technologies, and I wish the very best for this conference. Thank you. Jai Hind.
Thank you, sir. I request all the dignitaries on the dais to kindly launch the GUJCOST newsletter, December 2025 edition, highlighting key initiatives and achievements in science, technology, and innovation of GUJCOST. Thank you, everyone. We are also delighted to feature the launch of the conference souvenir in e-book format, documenting key deliberations and outcomes of the conference.
Thank you, everyone. We are privileged to have with us our chief guest, Ms. P. Bharti IAS, as Secretary, Department of Science and Technology, Government of Gujarat, guiding the state's science, technology, and innovation journey. A 2005 batch IAS officer of Gujarat cadre, Ms. Bharti combines the precision of an engineer, the vision of a policy maker, and the dedication of a public servant. With a degree in computer engineering, an LLB, and a master's in public policy. Thank you. Ma'am, you can.
Good morning, all of you. Our chief guest, Mr. Dr. Anil Bardwaj, Director, Physical Research Laboratory. Manoj Kumar Pataria ji, President, Society for Information Science. Our guests from Vietnam, Nepal, and Mr. Sai Baba, National Institute of Advanced Studies, Bangalore, and distinguished guests of the dais. Very welcome, warm welcome to all of you. And it is my privilege and honor to be here in this inaugural session of Science Communication Conference on Public Understanding of Quantum Science and Technology. I really thank GUJCOST for organizing wonderful conference. He has done meticulous planning and called a lot of people. I think around 8 to 9 states representatives are here, and from other countries 2 people are here, and from UK some also joining. I really congratulate GUJCOST for organizing this conference. All of you know today is National Mathematics Day, which is celebrated 22nd December. Which is the birth anniversary of Ramanujam ji. So, all of you know Ramanujam's life and work still influence number theory, physics, and modern computational quantum science. So today we are remembering him because his curiosity and talent, and we have to nurture it among our youngsters, which is our responsibility. And today's theme of today's conference is Public Understanding of Quantum Science and Technology, which is very timely and globally relevant. And today we are commemorating the International Year of Quantum Science and Technology 2025. You know, quantum technology is a century-old scientific revolution is now shaping the technology for the emerging sector, emerging fields. The emerging technologies, ultra-fast computing, highly secure communication system, precision sensing, and advanced materials. These are the emerging technologies for Gujarat and India. These are not only science and technology, but these are global, this gives the edge to our country for global competitiveness, economic growth, and also strategic capability. So preparing our people to understand, trust, and use these technologies as important as developing the technologies for themselves. And as all of you know, Government of Gujarat and especially Department of Science and Technology, since so many years we are nurturing this technology and trying to instill this scientific temper from all the youngsters. We have this GUJCOST, very vibrant institute, which keeps on organizing this type of seminars and all, so that our whole society, the science reaches to the society. We have an extensive network of regional science centers, community science centers, innovation platforms, research programs, STEM labs, and Gujarat has nurtured scientific curiosity across all age groups and geographies. And we also have Gujarat Informatics Limited, Gujarat Fiber Grid Network Limited, and we have our own director of ICT, and Gujarat Science City have played a very good transformative role in digital Gujarat governance, and we have very good public service delivery and large scientific outreach programs. And we also know GUJCOST has led lot of initiatives like RoboFest Gujarat, National STEM Quiz. It organized a lot of science festivals. It offers research grants and effective implementation of the state science and technology and innovation policy. And we are going to launch a new STI policy for the 2026. And we also have Gujarat, the only dedicated institute, GBU, Gujarat Biotechnology University. We have GBRC, we have GSBTM, which are advancing the technology in biotechnology sector. And also we have Institute of Seismologic Research, which is science, technology, and preparedness together can protect lives and build resilient communities. I'm particularly proud that Gujarat and especially GUJCOST has been recognized as a UNESCO academic partner for this year, Indian International Year of Quantum Science 2025. So GUJCOST has started a lot of quantum outreach programs. It has prepared hands-on kits, teacher training modules, student workshops, and public lectures, which has demonstrated that even the most scientific ideas can reach and can be made accessible and engaged and meaningful. So Gujarat, all of you know, we have a very strong industrial base, vibrant startup ecosystem, robust academic and research institute. So we are positioned to emerge as a leader in quantum communication, sensing and materials research and elite technologies. So the applications of quantum technologies, especially in cybersecurity, healthcare, finance, energy, manufacturing and defense, will have a profound impact on society and economy. So I look forward that this conference provides an important platform and to strengthen collaboration among academia, industry, government, science and communicators. So today's discussion and 2 days discussions and insights emerging from this conference will shape future policies, outreach strategies and innovation pathways. So I sincerely acknowledge and thank UNESCO's International Year of Quantum Secretariat, National Quantum Mission of Government of India, ISWA International, ISWA India, SIS and ISCOS for their valuable partnership with Gujarat. Quantum science is not merely a technological frontier, it marks the beginning of a new scientific era for Gujarat. So let us all together work to ensure that every scientific discovery travels the full journey from the laboratory to the marketplace and ultimately to improving the lives of our citizens. Thank you so much and Jai Hind.
Thank you, Madam. Now I invite Dr. Narottam Sahu, Advisor GUJCOST, to present a memento to Ms. P. Bharti Madam, IAS Secretary DST, Government of Gujarat. Thank you, sir. Now I invite Dr. Manoj Kumar Pataria, President, Society for Information Science, to present a memento to Professor Dr. Anil Bhardwaj, Director, Physical Research Laboratory, Ahmedabad. Thank you, sir. As we are near the conclusion of the inaugural session, we now invite Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST, to deliver the vote of thanks.
A very good morning to one and all. Respected P. Bharti Madam, respected Anil Bhardwaj Sir, Manoj Pataria Sir, Sai Baba Sir, Lan Madam and Anjana Madam, all the well-renowned distinguished guests of the dais, faculty members and research scholars who have joined us today for this Science Communication Conference on Public Understanding of Quantum Science and Technology. And what other day, better day to get this conference going than the National Mathematics Day, as mathematics is one of the basic roots in quantum technology. So I'd like to greet you on this National Mathematics Day as well today. With this, I would like to thank our chief guest who has taken her time and also delivered a very inspiring keynote for this particular conference. We are thankful for your kind support and constant motivation. We are also thankful to Pataria sir, who has been behind this conference and brought this to Science City. We are greatly thankful to Anil Bhardwaj sir, who has taken out time from his very busy schedule and has graced this occasion today. I'm thankful to the entire staff of Science City, ED Science City, for opening the doors of Science City as and when we require. And thank you so much to all the eminent speakers from SAC ISRO to our former Vice Chancellor sitting over here, and all the members who have come here all the way from across the country and outside the country to grace this occasion, and of course our participants who actually belong to across Gujarat. They have come from various universities and institute. So thank you very much, and wishing all a very successful conference. Thank you.
Thank you, ma'am. May I now request everyone to kindly rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. This marks the successful conclusion of the inaugural session of the conference. We now request all the participants to kindly proceed for tea.
hello, 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 hello.
clinic, huh? Oh.
I request everyone to please take their seats.
हाँ? पीछे मतलब यहाँ पीछे कहाँ क्लिप होता है? अच्छा अच्छा आप कर देंगे? हैं? अच्छा कोई बात नहीं फिर ये तो चल ओके हेलो आ रही है ना आवाज?
We are about to commence the first session of our conference. Please take your seats. I request everyone at the back having tea to please come forward and take their seats.
Welcome back, everyone. I hope you all had a refreshing tea break. We now move into one of the most significant segments of the day, that is keynote address, which sets the intellectual tone for the technical deliberations that follow. It is our privilege to invite Sri C.P. Sharma, Scientist Engineer G, Space Application Center, Ahmedabad, to deliver keynote address. Dr. C.P. Sharma leads satellite communication technology development and has contributed to key NAVCOM projects. His research includes next-generation satellite communications, 6G, NTN, and quantum communication. He is a recipient of the Nina Saxena Excellence in Technology Award 2025, ISRO Young Scientist Merit Award, and ASI Team Excellence Award. May I request everyone at the backside, please be seated. Thank you. May I now invite Sri C.P. Sharma to kindly deliver his keynote address. Help me in welcoming sir with a big round of applause.
Dignitaries, distinguished guests, and people from academia and dear students. A very good morning to all of you. So, the theme of this conference is the public understanding of the quantum science and technology. So, I have tried to keep it as simple as possible. So, many people it will look at trivial, but it may be beneficial for many. So, I will start from the key concepts and then the technologies which are presently under development and going to mature, and finally what at the Space Application Center and ISRO, what we are doing at the space-based system for the quantum technologies. So you might have understand that nowadays everybody is talking about quantum. So now why we are talking nowadays more about the quantum? The reason is that though the quantum technologies was invented long back around 1 century ago, however, now it has come moving from labs to the practical applications. So that is why now we are talking more about it. And why we are talking? Because this technology will impact all the securities, computing, sensing, and national infrastructure in a big way, which the classical technologies have the limitation presently. And the countries investing heavily on these technologies will lead the world. So as we know, Taiwan, you might have heard that Taiwan, TSMC is the biggest foundry in the world. So the Taiwan took the lead at that time in the semiconductor field, and now it has emerged as a global leader in the semiconductor technology. So that is why whoever start early will lead. So that is one of the main reasons. So, but the quantum technology, because it is a different from the classical physics, which we all can understand, that is why the adoption is slightly slower. So using this type of conferences, etc., will surely help to motivate the young minds to take up this challenging field. So this is a slightly old snap from one of the researchers, Capgemini, which was done in 2021. Means which are the countries which are leading this quantum. So as we can see that China is the leading in the quantum field, and then following by the Netherlands, and other countries are again doing something. Fortunately, India is also leading because of the efforts of the institution and the government support. As we will see in the 2021 at the Space Application Center, we demonstrated the first free space quantum communication. That was the first breakthrough in the country for the free space communication. So when the quantum is buzzing around, so a lot of things also should come in the domain of recognition. So you might be aware that 2022 Nobel Prize was given to 3 scientists, Allen, John, and antenna for experiments with the entangled photons. Means that we will see later, means two photons are linked together in such a way that their properties are linked even they were very far apart. So though they were doing all these experiments from 1990, however, it was not coming in a practical application. That is why the Nobel Prize was delayed. And finally in 1922, when the technology it came in the market, then all the world people recognized that it is a very challenging field, so they give the Nobel Prize to these people. So where this invention is practically used, presently for secure key generation, quantum computers, which are presently also in an infant phase, we cannot call that they have matured, it is a mature technology, but they are also in the development phase. Quantum internet, which will come in the future, timing synchronization, presently we are relying on the GPS, etc., which are based on the basic quantum concept, but using this entanglement concepts, etc., in future we will get a GPS-less navigation in the future. And that is why 2025 is chosen as a UN. 2025 is chosen as a International Year of Quantum Science and Technology. So if we see the history, means a lot of quantum related invention took place in the early 1900, and if you see this around 1925, de Broglie, Schrodinger, Heisenberg, they formulated the laws around 1925 that lead to the revolution in the quantum technology. So that is why, to celebrate that success, which put the foundation of this, the UN has declared 1925 as the International Year of Quantum Science and Technology. So from that onwards, a lot of practical aspects have been looked at. So initially the practical, it was limited to theory only, but later on, slowly the practical application emerged in the late 80s, and that has taken shaping the present quantum technology future. And this is one of the rare photos of all the greatest scientists, including Curie, Planck, Einstein, Bohr, etc. So in the 1927, one conference was held for the quantum mechanics in the Solvay. So to formulate the laws of the quantum mechanics, so that put the foundation of all the quantum which we are seeing nowadays. Again, I will come. Quantum is now a key to the future. So in 2025, again the Nobel Prize went to quantum tunneling. So as you can see in a picture, basically, generally quantum apply to the very macro level, I will say at an atomic, subatomic level. However, for simplification, we have seen this quantum tunneling as a phenomena where, suppose there is a barrier, if we throw a ball, there is if we go in a classical way, there is no chance of that ball can go outside, except it passes above the barrier and that. But in quantum, at the subatomic level, there is a possibility that without having the sufficient energy, it can pass through the barrier. So because of that, earlier it was applicable for the very macroscopic level, means at the atomic level, subatomic level. However, the Nobel Prize was given because at the subatomic level, this phenomena may not be useful. Because, so in the practical application, if we can have a advantage in terms of the macro level, means at the higher level, like suppose in a transistor, we can overcome a barrier faster, so we can make our devices very fast with the lesser current, etc. So this tunneling phenomena is now going at the macro level. So the Nobel Prize was given for the discovery of macroscopic quantum. This macroscopic is a new term which has now coming in the quantum era. Earlier it was a microscopic level, now it has coming to the macroscopic level. So in future, whatever we see in the movies, etc., means fascination in things, that will soon be related because when we go from the macroscopic to the bulk level. So just for the sake of completion, I will keep this definition, what is quantum. So quantum is a plural of quanta, which comes from the Latin word how much. So how much means it is a minimum discrete amount. The words are discrete. It should be a discrete, not a continuous amount of physical entity involved in an interaction. It may be small, but until it is involved in an interaction, it cannot be called a quantum. So as we see in the right side, there is an atomic structure. Like we say a matter, as an example, we take a water. A water is basically a matter. At the molecule level, we call it a H2O. And at the atom level, it is made of hydrogen and oxygen atoms. And further we go, then it becomes a proton, neutron, electrons. And later, in late 90s, again the proton and neutrons were further divided into the, say, quarks. So presently what is happening, quarks are, we are able to observe with them, but we are not able to involve them interactively. So for the practical purpose, theoretically quark may be a quantum of the atomic structure, but for practical purpose, presently electrons and these protons are the basically quantum of the atomic level. In future, if we are able to control them, the quarks, etc., to involve in an interaction, then they will become a part of the quantum. So the example of this is a photon, quantum. A single packet of light is called the photon. We cannot have half the photon. So it has a property that is a massless particle with an energy of hc by lambda. So it has a property that depends on the wavelength and the speed of light. Second is the electron also is a fundamental particle, and it lies in a discrete level, discrete words. Basically, it doesn't lie in a different continuous energy bands inside the atom, but at a discrete level. However, as you will see that these theories are continuously changing. In the quantum world, even the discrete is not applicable. It is called a quantum electron cloud. Means the electrons can be in a cloud. It has a certain probability to find at a particular place, not at a discrete. So means still there is a confusion, I will not say, understanding is going on because so many things. So quantum initially was applying to the ultra small atomic and subatomic particle, but as we see that 2024 Nobel Prize is given for the macroscopic level. So means our understanding is increasing and we are going at a higher level. When we reach at a bulk level, means like quantum teleportation, etc., which we will see later, then it will be a really useful thing for the whole generation. So it is a shift from the classical, why we are not able to understand all this quantum generally we see. So basically classical physics was based on the like gravitation or motion laws, or it is basically if you see the Newton's law of gravitation or laws of motion. So these were the rules of everyday object, the planet, railway, engine, objects. It works for the things which human can touch, see or touch or can visualize. However, at the subatomic level, we cannot feel, sense them. That is why we have to have a different type of analysis tool. We directly cannot see, but through analysis tools, we can see them, control them. So seeing and controlling are the two different things. One is the observation, second is the thing. So presently, it is a shift that it is replaced by the probability and wave particle duality. So, as I said, I told that quantum is basically, it is in a development phase still. So initial quantum revolution took place during the early 1900, and where we discovered the core concept like wave particle duality. So like on the right side, you are seeing a slide. This is a famous experiment which lead to the foundation of the quantum, one of the for quantum technology. So if we say it was a photon, means the light is emitted, it is falling on, it is falling on two slits, and from the outside, they get interfered, and the interference pattern is made on the sensing screen. So there is a wave pattern. So Einstein told that it is behaving as a wave. However, as soon as we put a photoelectric detector inside these two slits, above these slits, so it becomes a point target there. So this type of phenomena can occur when the particle behaves as a particle. So light behaves like a wave until measured. Means a element can have a multiple behavior like wave and particle together, and it retains one of the state when it is measured. So sometimes, suppose here we are sensing, it becomes a particle. Sometimes a particle may also become a wave. So how we measure it, how we do it, it depends on that phenomena. So the key principle which were in the earlier phase were the quantization and atomic structure. Means the electrons resides in a different quanta level. Atomic structure was evolved like Planck's, Bohr, Pauli that do. Then wave particle duality, which was the great invention by the de Broglie. Einstein was giving the particle theory. Earlier it was wave theory, but de Broglie finally gave it as a wave particle duality. And then came as a Schrodinger, that particle as a probability wave. Means particle is not a finite. It exists at a certain position as a probability. Means it is not a certain things. In classical physics, everything is a certain. But in quantum, the things are not certain. It has a certain probability. Then there comes the uncertainty principle from Heisenberg, which you may be learning in the next session, that we cannot determine multiple properties of element simultaneously, like say position and velocity. So in the quantum world, suppose we are able to determine the position accurately, we may not be sure about the velocity. It is basically, there is a limit to which this position and velocity can be determined to an accuracy. So this principle led to the experiments where we can observe the behavior. So the first quantum revolution was harnessing the collective, means bulk power of the quantum elements like atoms. It was, and observing the behavior. It was not going at the individual level. So emphasis was on the understanding rather than fully controlling the quantum elements. So the later on, the 1950s onwards, based on these principles, like we have a transistor, this is the foundation of our quantum computers, laser, MRI machines, and the atomic clock. They were using some of these properties, not of this. Because certain properties we were able to observe only, but we were not able to control. As the technology progresses, we were able to control also many of the properties. So the second revolution, which started in late 20th century, and that the theme was mastering the individual quantum state. So it started from observing to the mastering. So for mastering, we need to actively manipulate these particles, like electron protons, like electron guns, etc. So the core concept was treating quantum particles or the particles which have a qubits, which we'll learn later, as a unit of information. Because now everything is digitizing. So the information in terms of quantum elements, it is called qubits. So a qubit, in digital world we have say 0 and 1. But a qubit can have a 0 and 1 simultaneously, and it can have any intermediate states in between. So the key principle now which we were utilizing were the superposition. Means a particle can exist in the multiple states simultaneously until measured. So there are, if you see video, I say this dais is basically a solid thing. It is a particle or something. But in the quantum domain, it is a wave also until I see it or touch it. So for the universe, it has a dual. It is a wave also, it is a particle. But our present limitation is seeing as a particle only. But in nature, if we are able to control them, we can see them as a wave. So here the governing laws were the Bell's theorem. The Bell's theorem is for that, okay. It proves a non-locality, means whatever we see, the things here, what we in the classical physics, we see that the things are affected by its immediate environment only. So which is called the local phenomena. But in quantum entanglement, what happens, suppose we generate two quantum particles, one is on the earth and second is say thousands of light years ahead in the galaxy. Even though they are far apart, their properties are linked such that if we manipulate one particle, another will be affected. So the Einstein was proposing a hidden variable should be there in these entangled particles, such that when we measure them, this hidden variable comes into play, and that is why when we do the two measurements or alert one thing, other things correct. But Bales come with a equation which gives a pave to what means the classical physics can work up to a certain extent. Like we can transfer information more than the speed of light. Then only it is a basically quantum thing. So I will discuss this further. The primary application now it is coming in the drug discovery or cryptography computing, which is impossible with the present computer in a finite amount of time. Quantum communication, we call it quantum communication, but as we will go ahead, that it is presently not a fully quantum communication as we see in the digital world. It is basically presently limited to quantum key distribution, which is used in the secure communication. Like we see one-time password in our things. So such type of thing, it can be used. The quantum sensors, so the need is going to detect at a very finer level. So with the quantum structures, we are because dealing with the atomic level, we will be able to measure the things which are 1,000 times or more than accurate than the present measurements. So if we see the whole journey of the quantum, it started from 1900 and 1935, it is called Einstein-Palladium-Rosen paradox, where that entangled particle cannot have a non-local relationship, means they cannot be correlated beyond the speed of the light. But later on in 1964, Bell's inequality proved that wrong, and it was a theoretical concept in 1964 until it was broken by that present 2022 Nobel Prize that was given that. So it started journey from 1900, 1935, that the quantum entanglement was first discovered. Then 1964, the entanglement was explained by the Bell. And then the 1970 information theory, birth of the information theory, means qubits, etc. come into the picture. And then the quantum computer proposal comes in 1981, 84 quantum cryptography came. Then 94 the Shor algorithm was come. This is the main thing which is presently why people are debating. Shor algorithm told that given the power of the this quantum computer, the present encryption, which is based on our public and private key cryptography, which we presently are using, that can be broken easily. So that is why a lot of, then because all the nations have to protect their infrastructure, information, etc. So there are two ways they are presently going. One is the quantum key distribution, and second is the post-quantum cryptography, which you may be hearing right now. So that is one of the things which happened in 94. Then 2000, we have a first quantum computer, and this, because we want to control the quantum elements, these quantum elements can be controlled at a very low temperature, say, because in the absolute lowest temperature is minus 273 degree Kelvin. So until we control them, as we see that it has the multiple properties until measured. So if we want to preserve the properties, we should have a minimum amount of noise, etc. So that is why they need to be cooled at a super conducting stage. So like that, 2000 onwards, there are a lot of progress and a lot of companies have invested. And the recent year only 2016, 19, 20, lot of things are coming. So that is why 2025 now is a time for every country to take a lead in the step and start developing. So I will skip because I have already explained that initially it was transistor semiconductor, now it is quantum communication sensing. So key quantum principles which are on this is based. It is first is the superposition. Means a quantum particle can exist in all possible states simultaneously until it is measured. Means for that, a famous analogy is given in the literature. If you see, suppose it is a macro, we are seeing at a physical level. It is just for showing you the quantum phenomena takes at the atomic level, not at the coin level or the switch level. Just for your understanding, I am explaining this. Like a switch, in the electrical switch, 0 and 1 position. But when we spin a coin, we see a blurred image. A blurred Hello, we resume now. So, with the world, physical world, the analogy is that switch 0, 1. When we spin a coil, we see the multiple head and tail simultaneously. Sometimes we see head, sometimes combination of head, tail, sometimes that. So, means there are multiple states in which a spinning coin can exist. Until we measure it, means when we put a thumb above it, we will have head and tail. In between it has multiple states. So if somehow we are able to capture these multiple states and do the computation on that, then we will have a multiplied power to do all the computation. So this is the principle which the present computers are using, that they don't measure it, but when it is in the multiple states, somehow the utilizing the multiple state properties, these quantum computer are doing a calculation massively in parallel. So for a million possibility, a classical computer, even with quad core, octa core or many threads, it can do a finite amount of calculation. However, a qubit, because of the multiple states nature, can do a lot of parallel calculation at a simultaneously, because it is existing in multiple states simultaneously. Anyway, this concept will be explained in your later presentation. I was just want to touch that concept. Second is the entanglement. So it is the one of the most significant discovery, which though it happened in 1936, that when we generate two photons in such a way that they are generated with certain properties, that their properties are linked together irrespective of their distance. Means they can be anywhere. So if we alter one property of one particle, the property of another particle changes. So in science fiction film, we can see that at Earth we are changing something and it is changing at the other galaxy. So that time has not come. It is still that is called quantum teleportation, which is still under the lab research field. But if we utilize some of these phenomena, quantum entanglement, in a certain way, it will be very useful. So presently, like this quantum entanglement means they have the similar properties, is being utilized in the practical application by many of the agencies, including the ISRO, which demonstrated the quantum key distribution using this quantum entanglement. So as I told that measuring one entangled particle instantly influences the state of another. So suppose I want to send something, so I can do something on ground such that the similar thing occurs at the far place, if the things are entanglement. So this was 1936, 1935 around, Einstein, Podolsky and Rosen. They told that when the particles are so far apart, how can they have a linking together until there is a hidden variable hidden in the particle itself, such that their behavior is known with the time, that such that one particle, if we affect, other is also affected. So this hidden variable theory keeps on going. They propose that there is a hidden variable and the word is local, means nothing correlates beyond the speed of light. But the Bell provided a mathematical test which is called Bell inequality test, where it signifies that the world can be locally, universe is not locally real, means there exists a probability that we can have a entanglement which cannot be explained by the simple speed of light. So this concept has been proven in the laboratory by many scientists, and that is why the 1922 Nobel Prize goes that the world is the local realism is violated. The entire things are universe. All the things in the universe are linked, even they are very far apart. So one particle in universe and other on the earth, they can have a wave-like linking, such that when we affect something here on the earth, the other particle is affected. But as we see that as soon as we touch the wave, it goes in a particle nature. So the practical implementation is that without affecting the multiple nature of a quantum particle, how we can utilize this property. So this is the research which is going on presently. And some of the things we are able to control. Again, I told that earlier we told quantum atoms are residing in a discrete orbit. But in quantum theory, to explain that, that doesn't help. So that the electron do not move in a fixed orbit. They stay in a cloud where they are more likely to be found. Basically, there is a probability. So quantum gives a probability, not a certainty. That is why in the physical world or classical thing, because it is a probability, no certain, we are not able to digest it. We are habitual for seeing the things which occur in the certainty. When the things occur in the probability, we don't believe them. So just I will compare the classical physics, like we have a definite states, predictable behavior, and measurement doesn't disturb. Like I'm measuring this thing, it will not affect the system. However, quantum physics, it is basically states are not 0 and 1. In between it can be any state superposition. It is a wave particle duality. And measurement affects outcome. Means how we measure it, that brings that property of the particular particle. So one more theorem which is fundamental we presently utilize is the no cloning theorem. It states that arbitrary means we should not know a priori. Unknown quantum state cannot be copied perfectly. So in the present world where we have computers, we are doing a lot of transaction in the digital world. We can intercept that information such that the information going to the intended sender and receptor is not modified. But when we do in the quantum world, we pass the information using quantum world, means it cannot be copied until the sender or receiver know that somebody has intercepted it. Means adversary they will be able to know. So basically it is possible to encode information in some quantum properties that any effort to monitor them will disturb such that it is detectable by the intended sender or receiver. So like many of you may be knowing the physics. So basically presently in quantum computers etc. we are using a light. So light we send in a first state is a vertical polarization and second is a diagonal polarization. In vertical polarization also, so we call two properties. One is the basis, horizontal, vertical, a diagonal, anti-diagonal or bits. So we can see out of the 8 outcomes, only 4 can be known with the predictability and the 4 intermediate outputs have the uncertainty. Like when with the third diagonal we measure with the vertical basis, then what happens? It will be detected as a vertical and horizontal. So there will be error until we have some channel where we can communicate one of the properties to finalize it. Adversary doesn't have that channel. So in the present quantum scenario, what we are doing apart from the quantum channel, one additional channel which is called the classical channel, we use for the another information handshaking. With that information, all the quantum states are reconstructed. Our adversary cannot know because suppose he intercept one of the photon, but he will know only one of the property. So what he tried to duplicate it, but in duplication, because he doesn't know one of the property, 50% time he will be in the error in duplicating the information. So that is why this property is coming. No cloning. No cloning means you cannot copy it. You cannot copy means you can detect it, then it will be destroyed. Basically, when you detect it, it will be destroyed. So the intended receiver will not receive it. So the key will not be made. So using this no cloning, we have made some satellites based on which our present QKD, quantum key distribution protocol, are working. So the new age quantum technology. So it was the basic. Anyway, I tried to cover. It may be slightly heavy for you, but I tried to cover the basic properties: superposition, entanglement, and no cloning, which are the fundamental principles of the quantum technology. So what are the key technologies which presently exist in the world? So I will quote here the National Quantum Mission, which is targeted for the 8-year mission life like 2023 to 2031. It has 4 verticals, which is called quantum computing. So we are trying to develop qubit computer with a capacity ranging from 50 to 1000 qubits. And similarly, quantum communication, which is a basically satellite-based quantum communication, which we are planning, because when we generate a photon, it has a limitation of certain distance. As he told that when we transmit things, photons, etc., it should not have a interference, because interference will disturb its states. So that is why presently the ground-based optical fiber system from the quantum key distributions are limited to say 100 or 200 kilometer. But using the satellites, we can have a wider range communication, say 2000, or from the 36,000 also we can communicate, 2000 more than apart from 2000 kilometer, we can communicate using entanglement and single photon based system with the no cloning theorem. So that is the quantum sensing and metrology. It was an older field. Many of the things we have already developed, like magnetometers, atomic clock which is used in GPS, global positioning system. In global positioning system, because across the world we have to synchronize the clocks, and through the clocks the informations are correlated. So this clock need to be very accurate. So the accurate things are the subatomic particle transition. When the particle transition from one state to another, they emit certain frequency. This frequency is very stable. If we control the temperature of that particular structure, that is a very precise. So presently atomic clock like rubidium atomic clock, etc., and are being built across the world for the GPS systems. And in our normal receiver, GPS receiver, we use the simple clocks, but we keep on updating using the NAVIC synchronizer. So, like I told, the quantum communication, satellite, quantum sensing are develop quantum sensor for navigation, healthcare, and diagnostic, and quantum material and devices. Because the quantum can work at a very low temperature, and we need a property like tunneling, etc., superconducting type of structure, so that it consumes less energy. So this is also taken with the National Quantum Mission. So many organizations like Department of Science and Technology, including GUJCOST, and Atomic Energy Department of Telecommunication, DRDO, ISROs are involved, so that in the country we can develop this technology to a certain extent that we are not far behind the world. Because this, otherwise our reliance, like presently we are relying on the semiconductor on the outside foundries. We should not lag behind in this technology. So it is a great initiative taken by the Department of Space and Technology and the organization, including GUJCOST, which is very actively involved. Yearly, they do a lot of conferences and spread the awareness about this. So with this, India will be among the top leaders, US, Canada, France, Finland, China, and Austria in this field, if we achieve these objectives. So that is why involvement of all you young generation is very important, because you have to take this field, then you can go in the deep in these fields. So quantum computing, I just briefly touched. You may be, again I told that to solve massive complex problems, multiple variables, today's computer cannot handle. Like somebody might have had while doing a transaction like 128-bit SSL link, sequence key, 256-bit key encryption is there. So if we use a simple computer, we require 2 raised to power 256 iteration to find the key. But in quantum computer, what is happening? We have multiple states together at a given time. If we have n qubits, so we have 2 to the power 9 states simultaneously. If somehow we are able to utilize these 2 to the power 9 states effectively and do the calculation in such that some practical result can emerge, then this keys can be broken in the second. Presently, no computer has been made practically because maintaining all the 2 power 9 states, any state is practically difficult. That is why a lot of work in the cryogenic technology and to preserve these states need to be done. It is not a replacement of classical computer because a classical computer is devised for most of the tasks. However, because of the qubit, and there is a thing that it works on the probability uncertainties. So it cannot give the things in the real-time domain which we sometimes requires. So that is, it will be helpful in doing some complex simulation, optimizing, factorizing the things, which generally doesn't require an immediate response because it works on the probability, etc. So these two, quantum computer as well as the classic computer, will complement each other. Nobody will replace each other. So this is one of the things you might have seen outside also. So this is a structure that quantums, on the left side you may be seeing, right side is a Google-made quantum computer which has around 1000 qubits. So the primary elements are the qubits. Basically they are the photons. Photons are generated and their states are controlled at a super cryogenic temperature, like 20 millikelvin. It means it is going at the absolute lowest level. That is why the red block you are seeing on the left bottom, it is cooling the material to 20 millikelvin, which is near to the absolute temperature minus 270. Then only the properties of the quantum elements can be preserved. Then the further things control computer hierarchy occurs in a classical domain. But majority of the things, interactions, etc., some of the decisions taken at the quantum level. So this is the structure presently people are trying to make. And quantum communication, this is the field where a lot of progress has been done. So in the quantum communication is different from the classical communication that we are sending photos, videos, text, etc. Because they are all the deterministic thing we are sending. But in the quantum world, as we see that there is a probability and uncertainties are coming. So with certainty, with things we cannot send. So it cannot be used for the classical type of communication for sending video, information, etc. However, there are the proper applications where we require non-real time of type of things like key generation. So we can generate the keys which are not really required in a real time using the quantum phenomena of entanglement and no cloning theorem, such that we can develop a secure system. Presently, suppose somebody knows our key, it will be broken, and this key is transmitted through our normal channels only, normal computer network, internet network. However, if you use a quantum network like as shown in this diagram, we are using two entanglement photon to the sender and receiver. And they use some protocol to finalize the keys in the non-real time. Now, as we heard that no cloning theorem, that an adversary can means capture the photons, but as soon as he captured the photon, that photon property is lost. So that photon is not used in the key generation part. So that is the beauty that using this, we can generate a lot of secure keys, which is very significant for our strategic computation for the military, etc. So that is why in the National Quantum Mission, we have worked a satellite-based quantum communication system which can deliver keys to the very strategic user or financial hubs where there the very multi-million transaction takes place. So this will, in future also, this will be limited to some of the application only, not for the general user. But as we know that in 60, nobody was thinking of the transistor. There was a hardly 10, 20 transistor per chip. Now we are seeing a million chips. So after 100 years, it may happen that they may also, lot of improvement in the technology can be done. So in the quantum, we are at the same stage which we were at in the 1960s in the semiconductor. So that is why we need to put a lot of efforts to develop this technology. So this is the satellite-based quantum communication which we presently are using. So like I told that there are two properties on which the communication can take place. One is the entanglement photon based, where one of the satellite can generate two entanglement pairs of the photons using some polarization and bit definition. That two stations, intended user at the ground can receive them. And then using these keys, they can communicate through a classical communication. Means key is secure. So in encryption or secure communication, there are two things. One is the key, second is the algorithm. Algorithms are publicly known to everybody. What we are using like advanced encryption standard or in the public key algorithm, we are using a RSA algorithm, 2048-bit key, which works on the factorization problem, which quantum computer can solve. So here we are not going over that phenomena. We are going in a physical level. Physical qubits are transmitted to generate the bits, which are ultra secure. Nobody, adversary cannot affect them. So I will skip, otherwise it will be hard, like in the single photon based system, how the things works. So basically we transfer the bits securely using quantum key distribution. So information is coded in the four polarization like 0, 0, 1, diagonal, anti-diagonal. They are received at the intended terminal like Bob. Because Bob doesn't know in which polarization the sender has sent, so he randomly use some polarization sensing technique. So the polarization he can do anti-diagonal, diagonal basis or horizontal, vertical. He cannot do measurement in vertical, horizontal, diagonal, anti-diagonal simultaneously. Out of these four, only two, like plus, minus, etc. So many times it will fail and many times it will pass. So this will be, Bob will receive all these things, then it will pass the information, the basis in which it has received to the Alice. Then the Alice will again say some of the bases in which you have received are wrong, some are right. Using these protocols, which are called the quantum protocol, BB84 protocol, BB94 protocol, finally the keys are made. If the adversary come in the picture, it can only monitor and duplicate. If it monitor, the quantum state will be lost, because as soon as we monitor, the property is lost. Either the polarization property will be lost or 0-1 property will be lost. As I told, the quantum has the multiple property until it is measured. So one of the properties will be lost, because of which it will not be able to duplicate. So the adversary cannot do anything in the quantum phenomena which it can do in a classical world. So one of the topic was how the quantum, so when the people think quantum, it is simple photon or some electrons. It is not that. When we make a practical system, a lot of photonic technology, optical technology, electronics, all are involved. So to make a practical system, we need lot of elements which are tabulated in this slide, like quantum sources like non-linear crystals which generate the entanglement photon, and the lasers which generate the photons. And these optical polarizers and etc. are used to generate the polarization of these things at the sending end. Then there is a true quantum number generator. whatever keys we are generating, it should be a truly random, otherwise adversary will easily capture. So again, these true random number generators are not based on the digital pseudo-random binary generator, etc. But they are based on the some properties like vacuum noise sources, which doesn't have a Gaussian properties such that people cannot predict them. So this also we generate in the electronics using electronics or the noise sources. Then there is a quantum channel, which is a polarization maintaining optical fibers cables or free space link. And then there is this electronics using this FPGAs ASICs, where we can implement this protocol to do all the post-processing to generate the keys. And then there is a quantum detectors which work at a very low temperature, cryogenic temperature, like 4 degree Kelvin or less. There we can detect a energy of a single photon, which is a very small. Using these technologies, we have developed a system in 2021. This was the first breakthrough in the free space communication in the Space Application Center, where using these photons with red light, we communicate between two buildings which were 300 meters apart. And we used for the correlation of this, we used the NAVIC-based synchronization method, and we developed the secure key simultaneously at the Bob end, which is one building, at Alice end. In quantum, the keys are developed simultaneously at both ends. It is not that one people generate and another distribute. In single photon case, in entanglement photon case, one source generate keys for both. This experiment was based on the single photon, because practically there are no single entanglement sources are available which can work from the space. They will be lost because of the noises, attenuation, etc. So this was demonstrated again in Space Application Center, and using these keys, communication was done. Our present director, Nilesh Desai sir, was also involved, and he has taken the initiative, and because of that in the national quantum missions, we have got the 2 satellites approved for this quantum communication. Again, entanglement-based photon things we also did, where we took the help of PRL, Physical Research Laboratory, that developed this entanglement-based photon sources. All the other things was done by the SEC, and again we did the communication. These 2 key technology were, because of these 2 key technology and other efforts by other academia, that I showed in the 2021, India was considered as one of the leading fields in the this quantum technology. Presently, we are making, actually we have delivered, we have made a quantum satellite. Like you are seeing this photograph, here these 4 green things are the basically optical laser sources which are generating photons in 2 polarization and 2-bit patterns. That will be transmitted using these motors, these piezo drive things, and there is a scanning mechanism from space to ground, from 36,500 kilometers, such that when it reaches the Earth, it will be acting as a single photon. So we need to control with a precise accuracy all these sources, their alignment, etc. So which is a very key challenging technology. So we have used our 3-4 years to develop all this technology. We started from our basic experiment, and now we have reached to this level. Then there is a lot of electronics. I told that only photon optics is not there. There is a lot of post-processing electronics is involved. There we generate the photons, laser drivers, etc. So a lot of electronics is also involved in this practical system. So this we have developed. And for the sake of completion, I will complete this quantum sensing and metrology. Like in atomic clock, we are also using this quantum sensing from a long time, like atomic clock generation, etc. So basically, this will help in increase the precision with which we are doing the measurement, and we are producing the things. Like nanotechnology, we are producing a thing with very fine accuracy. So until we measure and control with the fine accuracy using the quantum particles, we cannot go with the precise measurement and reproduction systems. So these are the basic technology: quantum gravitometers, GPS-free navigations. These are the future technologies where we need to do a lot of work on this technology. So the current challenges are the decoherence. Means, as we know that as we sense it, the quantum properties, some of the quantum properties are lost. So we should have a lot of scattering, attenuation, heat, vibration occurring in our environment. So presently, all these quantum phenomena are taking place at a very controlled environment. Like we see in the quantum computers, it was cooled at a 20 millikelvin temperature. Second is the error correction we need to build. And sources and detectors, presently our speed is limited to few, like entangled photon sources or any sources. They are limited to few kilobits only. So practical application, we are going in a gigahertz or megahertz range. So this technology also need to be developed. And the cost of hardware is very significant because of this all cryogenic temperature related development which we need to do this. So this is the trend. Presently we are in the quantum key distribution atomic clocks. Future we will be going in the quantum Kira and then quantum simulation, quantum computers. So why students and young professionals matter? Because there is a global demand which is rising and needs physicists, engineers, software experts. And it has a lot of opportunity in academia to involve all the students, include a curriculum in their academic structure, then only we will be able to contribute to the world. So today's and current pathway in quantum technology means we have to develop a lot of electronics, photonics, cryogenic technologies, software algorithm, and policies standard. Because unless we make a standards, global acceptance will not be possible. So the key takeaway with this my presentation is that quantum now to the very significant level can now be understood and trusted. And awareness builds the confidence and the adoption. Until we have a belief in the system, people will not come. But seeing all this development now, you might be sure that it is going in a right path. So you can take your career in that path. So government support awareness by like GUJCOST, etc. is essential. Anyway, GUJCOST is doing a lot of work, and Department of Space Science Technology and ISRO, DRDO, etc. all are doing. India has a key role to play in the quantum technology. So that is why the theme is that public understanding is essential for the adoption. And I wish GUJCOST all the best in this endeavor. Thank you.
Thank you, sir. Now we invite Dr. Manoj Kumar Pataria, President Society for Information Science, to present a memento, Shri C.P. Sharma, Scientist Engineer G, Sec, ISRO, Ahmedabad.
Thank you, sir. We now move towards our first plenary talk, which will be delivered in virtual mode. It is our pleasure to welcome our distinguished speaker, Professor Kannan Purakayastha, joining us virtually for today's session from London, UK. The topic of the plenary talk is Heisenberg's thoughts on language and reality in quantum mechanics, important issues in the public understanding of quantum mechanics. Now I request Professor Purakayastha to address the gathering.
Morning from UK and good afternoon as well, maybe. Can you hear me?
Yes, sir, we
Yes?
can.
Okay. I'd like to express my gratitude to the President of the International Science Writer Association, Dr. Manoj Pataria, and Gujarat Councils on Science and Technology for informing me about the program and inviting me to talk at the National Science Communication Conference, organized by the Gujarat Council on Science and Technology, Government of India, in association with Society for Information Science, Indian Science Writer Associations, Indian Science Communication Society, International Science Writers Association, and also the International Year of Quantum Science and Technology. I am also grateful to Heidelberg Society, Munich, for allowing me to get access to various materials related to Heidelberg's life and work as a foreign elected member of the society. I have just listened to the excellent talk by Dr. C.P. Sharma. It's a very technical talk, so I will skip a lot of technical things that I don't want to speak, but rather I shall touch very briefly about the history of 1925, then Heisenberg's contribution to that history, Heisenberg's thought about language and reality in quantum mechanics, and last but not least, I will put forward a hypothesis for the science communicators engaged in disseminating the ideas of quantum science and technology. So I just delivered a lecture at the Göttingen University as well in Germany during their 5 days conference on 8th and 12th of September 2025. As you know, Göttingen is known as the birthplace of the quantum mechanics. And also there was a session held in Helgoland in June 2025, and also various quantum science and technology conference has happened in various parts of the world. And C.P. Sharma rightly mentioned that it is very much emerging, this quantum science and technology all over the world. So it's very important now. So why celebrating 100 years of quantum science and technology in 2025? I just like to say that in 2025, we have recognized that a century ago, the physics had its Darwinian moment, a change in perspective that was as consequential for the physical science as the theory of evolution by natural selection was for biology. So 2025 marks the centenary of Werner Heisenberg's paper that turned the quantum theory of the early 1900s into the quantum mechanics physicists are familiar with today. The title of the paper, you all know that the quantum theoretical reinterpretation of kinematics and mechanical relations. Heisenberg wrote this paper. He started writing it when he was in Helgoland because to relieve himself from the hay fever, that because Helgoland has got no tree, so he thought hay fever will go. But simultaneously, he got a very brilliant idea about this matrix mechanics. He sent his paper 9th of July 1925 to Max Born, and then Max Born on 25th of July 1925 sent it to Max Born to the Journal of the Physics. And they received it on 29th of July 1925, and they published it. So Heisenberg mentioned that the present paper seeks to establish the basis for theoretical quantum mechanics founded exclusively upon relationships between quantities which in principle are observable. So that is the starting point. And the same year, in 1925, Max Born and Pascal Jordan wrote another paper on quantum mechanics, received 27th of September 1925, and they also refer Heisenberg theoretical approach. and also Max Planck in 1900, and then Albert Einstein's 1903 to 1905. So that is one of the reasons we are celebrating 100 years of in this year, 2025. But we also know the Schrodinger wave equations came in 1926, and also Heisenberg, in his paper on helium atom, published in 1926, he referred Chaityandranath Bose from India, S. and Bose paper titled Planck's Low and Light Quantum Hypothesis, which was published in 1924, but Heisenberg referred in his paper in 1926, S. and Bose, and also Dirac's paper published 2026. So we can celebrate again in 2026 the quantum science and technology. So that's the background. Now, I now turn to the Heisenberg philosophy about language and reality in quantum mechanics. But in order to examine this, we need to explore first what Heisenberg did for the quantum mechanics. So we need to go back to the original source. And original source, obviously, I get access to a lot of sources from the Heisenberg Society, but for general public, we have got various documentation from the Nobel Foundations that Heisenberg received Nobel Prize in 1932. So at that time, the Royal Swedish Academy of Science press release said Heisenberg was awarded the 1932 Nobel Prize in Physics for the creation of quantum mechanics, the application of which has inter alia led to the discovery of the allotropic forms of hydrogen. Here is the challenge for the science communicator. For science communicator, allotropic forms of hydrogen should not be confused with the various isotopes of hydrogen, like protium, deuterium, tritium. These are two separate concepts. I will cut short my lecture because you have got a lunch as well coming. So you all know what happened in Helgoland, what Heisenberg did on 7th of June 1925 at 3 a.m. That time, the idea came to his mind about the expression of Niels Bohr idea into some sort of mathematical formalisms using matrix mechanics, though he did not know what is the matrix mechanics at that point in time, but he come up with idea, and then Max Born and his supervisor at that time, the Max Born and Jordan, they thought, oh, it's a very nice idea. We can translate everything into a matrix mechanics. So Max Born has got a more contribution there, but the fundamental idea comes from the Heisenberg, but he converted Heisenberg idea into matrix mechanics. But there are a lot of other stories. I'm not going there. I'm just skipping ahead. And I like to say in 1927, Heisenberg proposed the uncertainty relations, setting limits on how precisely the position and speed of a particle can be simultaneously determined. He mentioned that the more precisely you can specify the position of a particle, the less precisely you can specify the momentum, and vice versa. By specify means specify the range of possible values of. The range of possible values is called the uncertainty. The word implies something about what we can know or cannot know. That is how uncertain we are about the outcome of the subsequent measurement. This kind of language might seem to imply we can, in principle, know more than we actually do. And the limitations we are talking about here is a result of only our ignorance of lack of information. This is not the case. The limitation embodied in the uncertainty principle is a fundamental physical fact about quantum particles, not a reflection of a person's inability to make precise measurement. There are various philosophical point of view about the uncertainty principle, I wrote an essay for the Oxford Philosophical Journal, The Review, where I posed a question: is quantum uncertainty epistemic or ontological? The realist position, like Einstein, uncertainty principle is just an expression of the limits of what can be determined by measurement, or in philosophers' terms, the nature of uncertainty would be an epistemic one. The alternative philosophical position is to assume that the uncertainty principle is not simply a statement about what we can know, it is a statement about the nature of things. From that point of view, Heisenberg's uncertainty principle is a statement about how things are and what features they have. It is a statement about what exists. A philosopher would call such a position about the nature of the uncertainty principle an ontological one. I know I have got a lot of discussion with Anton Seilinger just a couple of months ago at Göttingen University about it, and he said to me, you know, the Seilinger already C.P. Sharma mentioned that he received Nobel Prize in 2022 with others, Alan Spector and others, and he mentioned that in a sense, the electron carries the possibility of many velocities at the same time, and the possibilities of being in many places at the same time. It is a direct consequence of the nature of waves. If we take it seriously, the Blois idea that a mathematical quantum possibility wave should be associated with each particle. The essential point here is that the Heisenberg uncertainty principle is a statement about the nature of things and not just about what we can know about the world. It's the nature of things. Now, in a Chicago lecture in 1929, Heisenberg maintained that the experiments of physics and their result can be described in the language of daily life. Thus, if the physicist did not demand a theory to explain his result and could be content, say, with a description of the lines appearing on photographic plate, everything would be simple, and there would be no need of an epistemological discussion. The difficulties arise only in the attempt to classify and synthesize the result, to establish the relation of cause and effect between them, in short, to construct a theory. I would argue that this realization triggered Heisenberg to formulate in a quantitative way a generalizable mathematical relations, which is now known as uncertainty principle. The word Heisenberg did not use. Heisenberg did not use uncertainty principle. He used different German language, which means indeterminacy. Later on in 1930, when his book was translated in English, then people like Wheeler, Dirac, they picked up the word uncertainty. Now I turn to concept, language, and reality in quantum mechanics, which is important for science communicators and public understanding of science. In Greek philosophy, the problem of the concept in language has been a major theme since Socrates. Plato's dialogue we see, but Aristotle seems created the basis for the scientific language through the logical analysis. Heisenberg knows that, but Heisenberg also knows about the oversimplification problem of the logical analysis. Heisenberg picked up Goethe, these German writers, Goethe's Faust, and where Mephistopheles speaks to his young student, waste not your time, so fast it flies. Method will teach you time to win. Hence, my young friend, I would advise with college logic to begin. That is the begin. That inspired by this passage, Heisenberg thought that science must be based upon language as the only means of communication, and where there is a problem of unambiguity, that is importance. But the logical pattern must play their part. Logic is the starting point, but not the end of science communications. So Heisenberg also observed that there are difficulties concerning the use of language arises in quantum theory. Here, as Heisenberg put it, we have at first no simple guide for correlating the mathematical symbols with concepts of ordinary language. And the only thing we know from the start is the fact that our common concepts cannot be applied to the structure of the atom. Here, the phenomena of the interference of probabilities would show up, which does not exist in classical physics. Heisenberg suggests that that's problem of the language here are really serious. So when we think about the scientific language, we need to see what Heisenberg observed in his time. Heisenberg observed that new discoveries and new ideas create a lot of scientific dispute and a lot of polemical publications. And, like me, I write every week scientific columns. So I picked up a lot of scientific ideas and things and the same. And Heisenberg put it, it probably means that one has not yet found the correct language. So this is indeed a fundamental problem for the things. As Heisenberg observed, a physicist has to speak about his result also to non-physicists who will not be satisfied unless some explanation is given in plain language, understandable to anybody. Heisenberg maintains that even for the physicist, the description in plain language will be a criterion of the degree of understanding that has been reached. Heisenberg posed a question: to what extent is such a description at all possible? When we are nowadays we are thinking about first quantum revolution, second quantum revolution, we are talking about entanglement, talking about quantum teleportation, quantum cryptography, quantum information, quantum dot, quantum objects, but this needs to be explained to the people who will use it. So language contains a great number of concepts which are suitable tool for communication about events in daily life. And Heisenberg observed, we can speak about a piece of iron or a piece of wood, but we cannot speak about a piece of water. The word piece does not apply to the liquid substance. We can cite another example about the limitation of concept that Niels Bohr mentioned in a story. A little boy goes into a grocer's shop with a penny in his hand and asks, "Could I have a penny's worth of mixed sweets?" The grocer takes 2 sweets and hands them to the boy, saying, "Here you have 2 sweets, you can do the mixing yourself." One can see the problem of the concept mixing here. Heisenberg observed that this intrinsic uncertainty of the meaning of words was of course recognized very early and it brought about the need for definition, where definition says for setting of boundaries that determine where this word is to be used and where not. But sometimes definition can be given only with the help of other concepts and so on. So there is, Heisenberg observed, one will finally have to rely on some concepts that are taken as they are unanalyzed and unidentified. So this word position and velocity of an electron, for instance, seem perfectly well defined as to both their meaning and their possible connection. And in fact, they are clearly defined concepts within the mathematical framework of Newtonian mechanics. But actually, they are not well defined as seen from the relations of uncertainty in quantum mechanics. In his word, Heisenberg, he mentioned in physics and philosophy, he mentioned in classical logic, it is assumed that if a statement has any meaning at all, either the statement or the negation of the statement must be correct. Tertium non datur is a Latin phrase. That means a third possibility does not exist. It may be that we do not know whether the statement or its negation is correct, but in reality, one of the two is correct. But that situation is not applicable in quantum theory. And Weizsäcker, one of the Heisenberg colleague, the Karl Weizsäcker, who was a German physicist and philosopher involved in nuclear research in Nazi Germany during the Second World War, who points out that one may distinguish various levels of language. Weizsäcker suggests, one level refers to the object, for instance, the atom or molecule. A second level refers to the statement about object. A third level may refer to the statement about object. So Heisenberg suggests that the classical logic would then be contained as a kind of limiting case in quantum logic. There should be a third possibility. You have got an atom. An atom is moving from one part of the box to another part of the box. In quantum situation, you have to combine this box and atom, everything together, and create a third possibility. And Weizsäcker then, thinking about this, then introduced the concept, the degree of truth. That degree of truth, that is, Heisenberg expands this by saying that this degree of truth implies decided, not decided, and not known. So for a science communicator, a lesson can be learned from here in reporting outcome of any scientific experiment. This is one of the aspects of reality in expressing the findings in quantum mechanics. Philosophically, the concept reality needs to be considered in various other ways. For example, if we wear a rose-tinted spectacles, then they will color every aspect of our visual experience. One may forget that they are wearing them, but they will still affect what one sees. Philosopher Immanuel Kant believed that we are all walking around understanding the world through a filter like this. This filter is the human mind. It determines how we experience everything and imposes a certain shape on that experience. Everything we perceive takes place in time and space, and every change has a cause. According to Kant, that is not because of the way reality ultimately is, it is a contribution of our mind. We don't have direct access to the way the world is, nor can we ever take the glasses off and see things as they truly are. We are stuck with this filter, and without it, we would be completely unable to experience anything. We know that German philosopher Schopenhauer, in his book The World as Will and Representation, come up with another thing. He is saying that there are two aspects of it. It exists both as will everything that exists. For example, it is the force that causes magnet to point north or a crystal to grow in chemical compound. The other aspect, the world as representation, that is the way we experience the world. So that is more or less, that construction is more or less the Immanuel Kant's that mentioned in his The Critique of Pure Reason, he mentioned about the phenomenal world. So there are the Kantian philosophical language of synthetic and analytic. We all know the synthetic knowledge is based on the experience or observation. Analytical knowledge does not require any experience. For example, all men are male, so that does not require any experience. It's an analytical things. But a synthetic is you have to experience things. If I see the lemon is bitter, that require some sort of observation to taste and to get. This is a synthetic. So that Kantian synthetic analytic knowledge, Heisenberg also thought about it, and he thought, is it possible the synthetic a priori knowledge is possible? The word a priori, I have noticed CP Sharma, Dr. Sharma also mentioned, and I'm very happy to listen to this word, that a priori. Heisenberg thought about the synthetic a priori knowledge, and he has done a lot of experiment, and he cited the radium and whether it is possible to predict the radium's emissions and other things, and he come back saying it is not possible. The a priori knowledge in quantum level is not possible. Heisenberg details mention all these things in his latest book, that reality and its order. It was actually he wrote this in 1941. Only. So that reality and its order, I received book and I review it for the Springer, published in various magazines and newspaper. You can go through and see what Heisenberg thought about quantum reality. I have no time at this moment, so I can't go in details about it, but I can I can see there are a lot of you'll get a lot of you'll see a lot of meeting happened with Heisenberg and Einstein, and he said Heisenberg said to Einstein said to Heisenberg, God does not play dice, you are playing dice with it, but Heisenberg replied, in quantum theory, natural laws deals with the temporal changes of the possible and the probable. The choice that lead from the possible to the probable, however, can only be registered statistically, but can no longer be predicted. So uh, these are the things. I think time is knocking. So I'd like to say that we know the public understanding of science is going hand in hand with the scientists' understanding of public. In quantum mechanics, this is more important than other branches of science because scientists have presented various interpretations today, and public and also policymakers also confused about it. As for example, the recent survey by the Nature, published in 30th of July 2025, that the 36% actually support the Copenhagen interpretations, and 15% saying the many world Bohemian mechanics, 7%. So there are several things, And again, scientists like Anton Seilinger say that there is no quantum world. He suddenly said in Helgoland conference that Anthony Seilinger said there is no quantum world. And outlining his view, he mentioned that quantum state exists only in his head, and that they describe information rather than reality. And then Ellen stand up and said, I disagree. And then, the Gerard T. Hooft, who received Nobel Prize in 1999, he said, we know superposition in the macroscopic world is nonsense, but that is clear. And I believe that in the microscopic world, it is clearly nonsense too. So these are you can see the superposition principle is saying nonsense. A Nobel Prize winner is saying this. So this reflects a deep philosophical difference about the nature of reality and the challenges Heisenberg noticed. He said, what exists is not what is seen. Heisenberg says we have to remember that. It's very important. We have to remember that what we observe is not nature in itself, but nature exposed to our method of questioning. That is the thing we actually observe. Our method of questioning. That's the things we observe. So, so for him, Heisenberg also mentioned in various places the concept of potentialities. A science communicator need to understand, which are not easy to understand. He was influenced by the Aristotelian philosophy, where he come across the word potential. For Heisenberg, probability function contains the objective element of tendency and the subjective element of incomplete knowledge. So this is a very important thing we need to understand. The probability function contains the objective element of tendency and the subjective element of incomplete knowledge. That is, and on that basis, I would like to put forward a hypothesis today. I did not put forward it before, even not in Göttingen University. I'd like to put forward a hypothesis here that the dissemination of quantum science and technology related idea to general public require harnessing the pragmatic positivist approach instead of logical positivist approach. That could be a potential PhD thesis for the young generations. You know, I can repeat it. I did not produce the slides, so I can repeat it. The dissemination of quantum science and technology-related idea to general public require harnessing the pragmatic positivist approach instead of logical positivist approach. One might say, what these two things? I'm at the last part of my talk, actually. So what this means? It means the meaningfulness. That means logical positivism focuses on the meaning of statement based on verifiability, while pragmatic positivism focuses on the usefulness and practical consequences of knowledge. Then, rejection of metaphysics. Logical positivism tends to reject metaphysics as meaningless, while pragmatic positivism, which is very suitable for Indian subcontinent, the pragmatic positivism is more open to different perspectives and approaches, including those that may not be directly verifiable. You know, in Indian subcontinent, a lot of cultural things are not directly verifiable. A lot of spiritual things are not directly verifiable. But you need to be open-minded. Emphasis on action. While logical positivism is more focused on the logical structure and verifiability of knowledge, pragmatic positivism emphasizes the practical application of knowledge and the ability to guide action. Here, you need to think about the lemon, turning lemon into lemonade. You are turning lemon into lemonade. That means use of quantum sensor in various fields you are trying to apply. And several parts of the world is going on, like Pentagon in USA cannot trust GPS system. So they are looking for quantum sensor-based navigation systems. I think Dr. Sharma also mentioned about these quantum sensor-based navigation systems. And then the methodology. Logical positivism often aligns with the deductive logic and quantitative methods, while in pragmatic positivism is more open to mixed method approach, combining quantitative and qualitative method. So in my opinion, Heisenberg was a pragmatic positivist, and we would like to harness his philosophy in our science communication, in our day-to-day public understanding of science. Philosopher Arthur Schopenhauer said, thoughts put on paper are nothing more than footsteps in the sand. You see the way the man has gone, but to know what he saw in his work, you want his eyes. So we need Heisenberg's eye in order to understand his thoughts about language and reality and apply his philosophy into our day-to-day understanding of science as a science communicator. Thank you for attending and listening my talk. Thank you.
Thank you so much, sir. The morning hours, it's I think 7:30 in UK. So he has got up. What happened? Keep the link on. So we are really thankful to Professor Kanan Purakastha from London, UK, who woke up early for our this particular session. So I think sir is still online, is it?
Yes.
Sir.
I'm online.
Yeah. So there is a few questions that we can take from the audience, if any.
Yeah.
Yes, anyone has a question? Any students there, faculties, if you have any question? Yes, anybody, any question on Heisenberg's uncertainty principle? The sir has so elaborately explained here. Anyone? Yeah.
Thank you, Dr. Kanan. We are delighted to hear your very enlightening talk that you have spoken from the heart and whatever from your experiences. That is really, we are all delighted. especially our youngsters, those who are attending the program. And it just triggers a question that this quantum is something like uncertainty, unpredictability, and predictability as well. Because I am going to ask a philosophical question first, then maybe followed by a few by some other experts or students. Things, whatever happening, any incident, it is believed that it's some harmingers, they start coming in before the incidents are taking place, and some indications started coming in. So, if they can be predicted or if they can be measured or sensed, can we predict the incidents? Cricket has a lot of physics, spinning of ball, and the Teflon on the surface of bat. Similarly, the cricket game also has some science. Can it be covered by the quantum theory or quantum mechanics? What you say?
Yes, quantum, because you can predict, but you have to have some range, and where this that is the uncertainty is arises. You can predict, you can't predict something 100% correct when you are doing something new. Something new. You have no prior knowledge and understanding. You are doing something new. You need to say, for example, you developed a sensor for climate modeling that is emerging now, that people are using quantum sensor for climate modeling. So you want to predict the climate modeling, but when you are predicting climate modeling with quantum sensor, always you need to give us a range of values. But obviously, it has been noticed that in comparison with the normal superconductor and normal sensor technology, the quantum sensor is much more accurate, and there is a lot of quickly you can do a lot of works there, and you get the range of value, and gradually your range is going down and down and down, and then the spread of the values will gradually go down. So as soon as that is one of the things, European Union, last conference, European Union and representative, they were present in London, in Royal Institution, in our two-day quantum conference, where they, are, they would like to see that because quantum science and technology, they are going for the funding mechanism to develop quantum computing and all of the things, but the error from the quantum company is much more higher. So everybody is focusing on the error correction of the quantum computing. As soon as they can address these error corrections, then it will come to general public. So still it is in a research stage, and as a result of that, European Union or policymakers, they sometimes hesitate to spend money for the quantum science and technology unless they see a clear path that something is achievable and achieved. Even though Germany this year, they actually gave the 10 billions, the Bavarian Science and Technology Group, they 10 billion euro they invested for quantum science and technological development. So it is coming. We need to reduce the error as much as we can, because on the Heisenberg uncertainty principle, there is a spread of values that when you are measuring. That is one problem. Another problem is what you is measuring is actually what you are questioning in your mind. So that's the reason he says that you are not really observing the things. Probably you are observing the things that the way you are questioning to observe. So these are the fine grain things uh, need to think about more, this, and also need to realize that even you are applying the probability functions, it has got an objective elements of tendency that is given the spread, and the subjective elements of your incomplete knowledge, because you are trying to measure something at one point. When you are measuring this one point, your measurement instrument is creating problem within the system, and that is called the measurement problem of the quantum uncertainty. So these are the things people are discussing all the times, but gradually going, we'll get quantum computer at least in our hand. Some people are predicting maybe within 20 years we'll get quantum computer in our hand. There are a lot of big development happen in the past. Like as for example, the laser-induced method that I personally work in 2013 in Kyoto University, Japan, with a laser-induced pumped and treat method. The instrument is very big inside a laboratory. Now Japan's is trying to change the dimension of the music into a handheld, same instrument in handheld instrument, so that people can go with this LID and can monitor the hydroxyl molecule loss in the atmosphere. So we are very hoping, very enthusiastic about this quantum science and technology, and I spend a lot of time now, uh, discussing this sort of thing. Yeah. Hopefully, I answer your
Yeah.
question.
Thank you, sir. Any question from the audience? Yes, we have a few hands raised. Just a minute. So we have a student entrepreneur here who would like to ask some question.
During the transition from classical to quantum mechanics, EPR had published a paper, and it protected relativity concepts, and quantum mechanics challenged relativity concepts. And there was then Bell's inequality. Bell's inequality was proven wrong. So quantum mechanics directly challenged the concepts of relativity. Do you think there is any chance that the base, the bound by nature, Heisenberg's uncertainty principle, below some, at an extent, we cannot have, we need to have some error. We cannot be more precise than that. Do you think there can be any other theory in future that will directly challenge Heisenberg's uncertainty principle and somehow prove it wrong through quantum mechanics?
Yes, that is already going on different places. Different places. There's exercise is going on, but not yet to come up with some sort of idea that verifiable ideas. As for example, very recently in Sydney, probably we'll see they are trying to come up with an alternative idea of the uncertainty principles, and it is like a balloon. You think about a balloon, and a balloon, if you push one side of the balloon, then it will expand in another side. So if you that means if you can if you can apply some sort of momentum in one part of the balloon, then automatically from momentum can predict the position. If you put a dot, if you put a hundreds of grid in this balloon, and each of the the grid, you put a dot, for example, and then you push one part of the balloon, you will find balloon is expanding, and then uh, position of the dot is moving. So some experiment is going on around the world to saying that, okay, we don't need to, Heisenberg said you can only measure the position and momentum, you can't measure at the same time. So probably if we know the momentum, then such experiment can predict the position. We don't need to measure both position and momentum at the same time. So this sort of experiment is going on all over the place, not yet finalized, but probably we will see. Some of the paper will come up, and then it has to be verifiable, So, this is the beauty of science. Science change all the times, come up with new ideas. And, there you go, from the Max Planck to Einstein to De Broglie, and several other people's emerges in this. So this is a very nice area of research, both philosophically and technically. You can come up with different ideas theoretically. So not yet proved, but there is a possibility it can be wrong very, very near futures. So we should not ignore it. So there is the beauty of this. But obviously, what sort of methodology we will apply on that to understand the reality. And I also mentioned we have to remove our red tinted spectacle from our spectacles so that we can see, able to see, so how we'll able to see, how we'll control our mind. So all sort of issue is there. It's a very interesting ideas, obviously. Future will tell only. Thank you for your question.
Thank you, sir. With this knowledge-filled session, the questions are actually never ending. But still,
Yes.
we can have one last question if anybody has. Yes, so we will take one last question, sir, from...
Hello, sir. Good morning. I am Nishil, and I am master student. So, your session was great in a philosophical sense as well, because physicists are often philosophers most of the time. So, my question is on your pragmatic positive approach. So, what safeguards does this pragmatic positive approach has against, let's say, creating some misconceptions or persistent misconceptions about quantum science and technology? Thank you, sir.
In pragmatic, because logical positivism, when we talk about, we basically rely on the philosopher Auguste Comte from the France, a French philosopher Auguste Comte. So he come up with the idea of this logical positivist approach. And Heisenberg and various places he thought about the logical is okay, logical is the starting point. We need to think about when we apply anything, the pragmatic logical positivist is completely focused on the verifiability. But the pragmatic positivists, they think about the practical consequences of this knowledge, and they also think about the usefulness of the things. So that is the first things they think about, and they also in pragmatic positivism they embrace actually the metaphysics. They don't reject the metaphysics. They are in logical positivism they reject metaphysics completely. They think it's meaningless because it is not verifiable. But in pragmatic positivism, that is, they're open. The pragmatic positivism opens, and so they think about the different perspectives and approaches, without rejecting everything. They think probably when you are trying to observe something, maybe it is disturbing your experimental systems, to look your instrument first, whether it is, and in microscopic field, it can disturb, but how you can control this disturbance. And there are a lot of research going on around the world about it. So that is the thing. And the emphasis on actions, there are a lot of logical positivists, they are based on just logical structure, but pragmatists always think about the practical application. Yes, I do a lot of theoretical work, mathematical work, but always back of my mind, I always think, what is the application of it? And if you can think about your application side very clearly, then you actually understand the problem. So that is also Heisenberg mentioned, that you have to every emphasis on, that you want to convert, that I mentioned, that the lemon to lemonade. So you need to lemon is a bitter, but when you are drinking lemonade, probably nice taste and things. So in order to convert, you need to think about it, that you are using quantum sensor and different part of the world, they're using quantum sensor for air quality monitoring, their quantum sensor, trying to apply it for the the climate modeling things, and also the methodological things. In the fundamental difference between the logical and pragmatic is pragmatic. Uh, uh, the people, the pragmatic positivism approach, they take account of both qualitative and quantitative approach in their research work. Just not the it is not just quantitative, rather they approach the problem both qualitative and quantitative. But logical positivism, they think about the deductive logics and quantitative methods. So this is the way Heisenberg thought, and he did not mention this. He thought, and I thought that, okay, if I synthesize all his thought process, then it directed me towards philosopher Quine, American philosopher Quine. So because he's directing towards it, um, uh, that so what I see and what is exists is not what I see, because I might see something, it does not exist. I see something, probably it existed before, and then later on I am observing it. So so this sort of approach. So we need a both quantitative and qualitative approach, and as a result of that, there are some fundamental difference as well in researching quantum science and technology and applying it. Hope I answer your question a little bit.
Yeah, thank you so much, sir. All the questions will never end with such kind of a lecture, but still, I take this opportunity to thank you for giving such an enlightening lecture. And in virtual mode, I would surely like to felicitate you. Also, we would hope to see you soon here in a physical manner here in Gujarat. We invite you here to Gujarat Science City, our Guj Coast, and so that we can have more interaction and more knowledge sharing from you. So thank you so much.
Thank you.
Now with this knowledge-filled lecture, we are coming up with another way of seeing quantum science. It is quantum sensors, seeing the unseen through folk science. So the team of Dr. V.P. Singh will first, I think, take up some way of taking quantum to you, some very unique way of taking quantum to you people. And then I think Dr. Singh will himself describe as to what he means by saying quantum sensor, seeing the unseen through folk science. Thank you.
Namaskar. Quantum science, quantum sensor, quantum science and technology. So many words we are listening from the morning. Now you listen something else by folk communication, how quantum science and technology can be communicated through folk media. So we will invite our participants to present a show on quantum science and technology, how it is useful to the common man. Please, go ahead.
चलो खेत में चलते हैं। अरे आज फिर धूप तेज है, मिट्टी में नमी कम लग रही है, क्या करूं?
राम, तुम्हारी चिंता दूर करने के लिए इस बार नई चीज लाया हूं, क्वांटम सेंसर।
अरे क्या लाए हो? कुंटल ससुर? यानी आप अपने कुंटल पर वजन वाले ससुर जी को लाए हैं? वह हमारी मदद करेंगे, लेकिन है कहाँ? दिख तो नहीं रहे। आप इतने भारी भरकम वजन वाले कुंटल ससुर दिख तो नहीं रहे।
अरे राम, कुंटल ससुर नहीं, हम क्वांटम सेंसर की बात कर रहे हैं। यह एक छोटा सा यंत्र है जो खेत में मिट्टी की नमी, पोषक तत्व सब कुछ मापता है, बिना खेत को छुए।
यह यंत्र कैसे काम करता है गुरुजी?
आखी, हमारी खेत की मिट्टी देखो।
मैं क्वांटम सेंसर हूँ। मैं बहुत छोटे छोटे कणों यानी क्वांटम फोटॉन्स को भेजती हूँ, जो मिट्टी के अणुओं से टकराते हैं, और जब वो वापस आते हैं तो मैं उनकी स्थिति पढ़कर बताती हूँ कि मिट्टी में कितनी नमी है और कौन से पोषक तत्व कम है।
अभी तक तो हम मिट्टी खोदकर धान के पत्ते देखकर अनुमान लगाते थे, लेकिन ये तो कमाल का यंत्र है।
हाँ, और अगर मिट्टी में ज्यादा पानी हो तो आँखी हमें बता देती है ताकि हम पानी बचाए।
बिल्कुल सही कहा पिंकी, क्योंकि पानी की एक एक बूंद अमूल्य है। क्वांटम सेंसर बहुत संवेदनशील है, यह एक बूंद भी की खबर देता है। इससे हम सही पानी और खाद दे सकते हैं, फसल भी अच्छी होगी और खर्च भी कम।
तो अब मैं रोज सुबह आँखी को खेत में रखूंगा और उसकी रिपोर्ट सुनूंगा और उसके आधार पर काम करूंगा।
मैं हमेशा तैयार हूँ किसान साहब। हम आपके साथ मिलकर खेत को हरा भरा बनाएंगे और भरपूर फसल उगाएंगे।
हुर्रे! क्वांटम सेंसर की मदद से हम भी विज्ञान के जादूगर बन गए हैं। खेत में खुशहाली, क्वांटम सेंसर की यारी। खेत में खुशहाली, क्वांटम सेंसर की यारी। आप भी बोलिए,
खेत में खुशहाली, क्वांटम सेंसर की यारी।
खेत में खुशहाली, क्वांटम सेंसर की यारी।
खेत में खुशहाली, क्वांटम सेंसर की यारी। खेत में खुशहाली, क्वांटम सेंसर की यारी। तो ये यारी हमें रखनी है। दिस इज द क्वांटम सेंसर। हाउ टू कम्युनिकेट क्वांटम सेंसर टू द मासेस, पर्टिकुलरली द रूरल मासेस। अभी वो हमें लगता है कि क्वांटम सेंसर पता नहीं कौन सा जादू है, कौन सा हुआ है। तो क्वांटम सेंसर को हमें आम आदमी के लिए कितना उपयोगी बना सकता है, ये हमारी लाइफ को यहाँ पे ये बताया गया है। एंड दिस वाज प्रेजेंटेड बाय, प्लीज कम, आप लोग आ जाओ। the members of the Gujarat Science City, इनके लिए जोरदार तालियां और अपना परिचय दे दीजिए। गुरुजी अपना परिचय देंगे।
मैं दिव्याकांत चौधरी CSC नवसारी से।
आनंद कुमार वाघेला IP ऑफिसर महसाना।
भूमिका वसावा IP officer from Narmada.
In this show, I play the role of Pinky, and my name is Krishna Kalathia. I am working as a IP officer at Botad district.
So this was all about the quantum sensor, and this story is a playful way to show how a quantum sensor works. No, you please be here. Please be here. वो podium इधर आ जाएगा. Podium this way. बस ठीक है। Tiny light particles, the sensor's eye, this aankhi, the quantum sensor shoots out photons, but particles of light, please keep it, that are special quantum state. Because of the quantum machines, each photon can be in many states at once. That's upper superposition. When the photon is something like a water molecule in the soil, which we have described here, it interacts and the photon state changes in a predictable way. And the reading that change. The sensor then measures the photon when it comes back. Because the photon was in superposition, the measurement gives a very precise clue about the property it touched. That is, how much water is in the soil. The tiny change is far too small for normal camera to see, but quantum enhanced detection can pick up it. This is the quantum. Why it is better than a regular sensor? Ordinarily, sensor is really a large classical signals that can miss tiny variations. Quantum sensors exploits the wilderness of quantum physics to achieve higher sensitivity and lower noise. So they can detect a single molecule of water or a whisper thin layer of nutrients, which was depicted here. Both are required for the farmer's field. Entanglement. In some advanced designs, two photons are entangled, their states are linked no matter how far apart they are. Measuring one instantly tells about the other. The teamwork lets the sensor make even more precise measurements than a single photon could. From lab to land, which we are doing here. The puppet show uses a cute robot, the sensor, the aankhi, to illustrate the real device that can be placed in the field. It's a small device. In practical, engineers built a teeny chip with laser. It is not, that's why it has been shown just smaller than the others. Superconductors are especially treated crystals that create and detect these quantum photons. The data are sent to the farmer's phone, giving a real-time readout of soil health. So why this is useful for the sustainable farming? Water saving, number one. Detecting exact moisture level means irrigation only when needed and where needed, which place it is needed. We are using sprinklers. So sprinklers can be connected with the superconductors. So there the role of quantum science and technology applies. Fertilizer use. Spot checking, nutrient level, reduces excess use of fertilizer, protecting waterways. Yield boosting, this is the main motto. Precise care leads to healthier crops and higher harvesting. So the puppet show was the magical robot is really a stand in the sophisticated piece of quantum technology that turns the invisible world of atoms into useful information for everyday farmers. The science may be complex, but the idea is simple. Use the strange rules of quantum physics to see what we can't see and act smarter because of it. Thank you very much. Thank you, Quantum. Namaskar.
Thank you very much, sir. And once again, I would like to request the audience to kindly give a big round of applause for whole team. Thank you, sir. Now we invite Dr. Narottam Sahu, sir, Advisor GUJCOST, to present a memento to Dr. V.P. Singh, Executive Secretary, Indian Science Communication Society. Thank you very much, sir. We request all participants to kindly proceed for lunch. Lunch arrangements have been made for the experts behind the backdrop, while participants are requested to proceed to the garden area for the lunch. Also move from the left side of the backdrop for the lunch area. Thank you.
In the interest of time, we are squeezing the lunch time to half an hour. So requesting you all to be back by 2:30.
Scientific language by yourself, but how the people will own it? Because this meeting is to do R&D, and I'm hoping that in Gujarat also that event happened. But the governor has made a beautiful point to say that why you people are not simplifying the scientific language for the better understanding of the people. I think this is the greatest lead for scientific community to understand. Then the science communication, how it is important. For example, we had a different subject, bioinformatics. Now we talk about AI. Of course, now we are in the process of quantum science and technology. But the bioinformatics, the subject, supposed to revolutionize our country. And after our Human Genome Project, I think Human Genome Project, all the students will understand how it really very important to us. But fortunately, the Human Genome Project and our science, what we have done, for all the engineering students, and especially the computer science and EEE and biotechnology student, and so that they can bring out a wonderful product or the solution for the problem which we are discussing today. So if you want to really convert the quantum science and technology for the benefit of the people, and I am sure that most of our students come with a technology developed ready so that we can solve many, many problems. This is one important point we should really take it very seriously. The second important point, the student community should also understand most of the time in terms of advanced science, we miss very basic. And in fact, I am very happy Srinivasa Ramanujam photo is here. He is the reason for mathematical, and he is given a greatest things to the world. How the Indian system, and especially the mathematical system, is vital to the entire world. But unfortunately, the students are missing the basic mathematics, basic physics, basic chemistry, and basic biology. And I want to tell you, this forum should really, one side we talk about the quantum of highly profiled subject, but if you could miss maths, and whatever point you can do, you cannot do anything beyond it. So I request the scientific community as well as the student should understand the basic mathematics, physics, chemistry are important to communicate as well as to develop technology of this high profile science. So that's why even now we are wondering whether AI is going to help to us, because most of the students are not taking basic mathematics. So now it's high time we should really discuss more on this so that the quantum science and technology really help our country to solve the problem we discussed in the morning. Thank you so much for this initial remark. Thank you.
Thank you, Professor Vincent, for highlighting on this science communication and its importance. And I would like to ask the floor if there is any questions for him. Please proceed. Any questions from scientists, students, or faculty? Yes, Professor Patalia, please proceed.
Students to put in English medium schools. So this is the context, how do you see this regional language are still relevant for science communication? And if so, what is the estimate?
So, thank you so much, sir, for your wonderful question. But before it, I should really compliment you. Your role in communication as a Manoj Pataria, I know, and in DST, you really played a greatest role. But you have a vital reason to ask this question. And I have my opinion. When you want to make in a regional language, more than the curriculum, I think we should really demonstrate to the student community, as today the Gujarat Council is made a beautiful drama like this. I think most of the complicated subject can be taken in the classroom, even it may be in a mother tongue, where we can ask the student to perform well into the process by understanding the concept. I am confident today, just because of a play, which really most of us could understand what is quantum science and technology, even hearing from an expert talk. So I think it has a powerful tool when you really make a kind of play by the student with the support of the faculty member, and most of the complex subject of science which we can understand. This is one side. Second, a state like Tamil Nadu. Now, the textbook society of Government of Tamil Nadu is translating most of the complicated science textbook in simple form, and that is in Tamil. So, and even, for example, cell biology by D. Roberts. Now we have a book in Tamil, and because it's very difficult to translate D. Roberts in cell biology. But another great thing, in medical colleges, and almost all subject has been translated into Tamil, and which is released by our CM and some 3 months back. So I think this effort should be promoted in almost all the places and all the states, so that I am confident our students will understand the science concept very well, so that more Nobel laureate will come from India. Because this one drawback, even today we are seeing why we are not able to get more Nobel laureate in our soil. But our people, when they go out, they become a greatest winner of Nobel Prize. But it's our time, and we should ensure our students should get, and the role of teacher is very, very important. More than a scientist, I think the role of teachers is very important, so that, and we can really create a wonderful ambience to our student community, and one day or other, and India will popular in science and technology. And apart from this, our country is going to be even shortly number 2 or 1, because now we are in 6th place. But when we prepare our student community towards it, and we will be number 1. Thank you so much for this wonderful question. Yeah.
Professor Dr. Pataria, thank you for the question, as well as Professor Vincent, thank you very much for your satisfying answer to the question that has been put forward. And if there is any more questions, I would like to entertain. Yes, please.
Sir, my question is on the same terms, regional languages, right? So what I'm asking is that when somebody is explaining something in regional language or regional tribe, so there are technical terms in quantum science and technology. So how should one compromise that so that understanding is not taking in between both the sides? So
please give your brief introduction as well with your name.
I am Nishil, and I am doing my master's from Ahmedabad in physics. Thank you, sir.
I think this question has a value. Most of the time, science communication, normally we will translate the tough and the very difficult science into vernacular language. As you rightly said, now this is another role we're supposed to play. All in the language or the word which is very difficult to understand, I think should first bring a equal word to the respective languages, number one. Still you should do that. After that, there is a clear description. For example, even in the morning somebody made a presentation, he defined what is quantum in English. Similar definition should be also coming to the local language. That time people can easily understand, first of all, the equal word. For example, in software we call, in Tamil we made menporul. So it's a menporul. If you ask any student in Tamil Nadu, if you say software, they will say it's a menporul. Similar things should also we have to develop. So that I think we should still communication people should play a greatest role. Their role is not end, and we should really make a few more roles so that we can really bring the equal word, then the description in vernacular language. Thank you.
Thank you very much for your energetic and really inputting forcefully how the communication should be done for quantum science accessible to all. Thank you, sir. Now, since we are running out of time, I would like to move to the second speaker. Right now we have the respected second speaker is Dr. Brinder Kumar Tyagi. And I would like to go for a brief biography of us. So, he is a seasonal science communicator and innovator, expert with nearly 3 decades of experience in designing and implementing nation-level science and technology communication program. A former scientist, at Vigyan Prasad, that is from DST, Government of India, and currently adjunct professor of CSIR, NISCPR, New Delhi. He has made significant contributions to STEM, education, innovation, mentoring, and research-driven science communication, particularly for diverse and marginalized communities. He holds a PhD in science and technology communication and has authored a book chapters, journal articles, and conference papers, besides developing innovative STEM learning kits and contributing to India's National Science and Technology Communication Framework. With this, I would like to request Dr. Tyagi for a talk about 3 to 5 minutes. Thank you, sir.
Thank you, Dr. Anjana. I think just I'll start with one distinction, because when we talk about science communication, and generally we overlap with the science education. So science education एक अलग है, no doubt there is a overlap between both the subject, but if somebody is maybe reading in the English medium, but he may not opt for the science subject. So that means like the general public who has not studied science, they are also our target group. And question main challenge is to communicate that science with them, because as a communicator we face when we even communicate the normal science. And now we are talking about some science which is evolving. No doubt 100 years of quantum science we are celebrating, but still the things which were established earlier, which now those has been, you can say, not wrong. So it is an emerging area. And same is with the technology. No doubt the technology is showing a lot of potential. In whatever Dr. Sharma, that presentation we have seen in the morning, बट उसमें हमेशा एक डाउट रहता है हमारा ओवर एक्सपेक्टेशन का, और ओवर एक्सपेक्टेशन में जब हम बात करते हैं तो हमारा जो एग्जाम्पल्स होते हैं, एनालॉजीज जो होती है, वो गड़बड़ हो जाता है. बिकॉज आई हैव सीन many popular articles so called on the quantum science and technology which appear in different magazines. It is a literal translation taken from some English magazine. It has not been culturally aligned, language-wise aligned with Indian scenario. If we look at the diversity of India while we communicating any science, forget about the quantum science and technology, because here even as a communicator I find a difficulty in terms of, because mentally I have been trained in a classical physics, Newtonian physics with a cause and effect thing, determinism, result is tangible, but here I am talking about totally something which is not seen, which is not tangible, unlike digital technology. Now here, how should I explain? Because most of the so-called just now established principles, those are counterintuitive, जो हमारे logic से बिल्कुल अलग जाता है. So first is like as a communicator, I have to train myself into understanding of this quantum physics and technology. I have to keep myself updated. Only then, I can communicate it further. And also, as a communicator, I have to see the diversity of like India in which we are living. It is at a social level, economical level, and geographical level, literacy level. So, how despite and till now we have not able to develop a system for communicating quantum science. So we need a total paradigm shift, like the quantum physics or quantum science and technology has done to the main science. Same way we need to come out with altogether a new framework of science communication in India, keeping its basic requirement. It will be for the school-going student, then even for the housewife, working women, farmers, because the technology which will be emerging from this science, I think it will be affecting the life of all walks of people. So they need to understand, and also it is also necessary because if we look at the Indian thing, I think more than 6,000 crore has been allocated for quantum mission, and it is a government money. So what is the output? What is the outcome from the laboratory? As a citizen of India, I should ought to know. So that's why I will be able to question or understand it properly when I have the understanding of that subject, which is not there. So in that case, I remember when the concept of scientific literacy, which was introduced in our syllabus in 1992, because whatever the science we are studying up to 10th standard, sir, it is a part of scientific literacy, where the UNO and UNICEF has played a role. But now this has to be introduced at the school level. Certain concepts which are well established, because the method of science through which we are trying to understand the classical science, there may be it is altogether at variance with that. So how that mentally accepting something which is going against the established logic or our established understanding of the science. So it need a total change of mindset also. Switch off, switch on. Classical, quantum. I'm trying to understand this aspect with reference to quantum physics. Switch on to that. Switch off to that. Because if we talk about the scientific temperament, it is mainly coming from the classical understanding of science. But when we talk about the quantum physics, because it is defined all the well-established logic of classical physics. So this mindset need to be changed from the very beginning, from the school level, It should be a part of our regular curriculum, and the people who are not covered with as a part of into the formal science or formal education, we need to devise special strategies, whether it's with an open school or I don't know, because I haven't thought yet at that level, but this is true. Definitely we need a total new framework of science communication as far as quantum science and technology is concerned, because it's going to affect the life of all of us in future, and we should be ready, because we are entering altogether into a different era in terms of science and technology. So thank you. I hope I have conveyed all the points which I was thinking very important.
Thank you very much for the talk, Dr. Brinder Kumartyagi, sir. Now, I would like to open the floor for the participants. If there is any questions, please proceed. Before that, if there is, if the participants are still thinking, I would like to put forward one question to the first speaker. What makes quantum concepts difficult for the public to understand? Professor.
Before me, the distinguished scientists sitting over here, as well as my colleagues in the Gujarat State Assembly Council and others. So I represent the state of Arunachal Pradesh, the land of rice. In these directions, almost 10 to 15 books has been translated in various dialects of our state, of the communities. So now the younger generations of our state, that the children and students are very much anxious and as well as very much talented in learning new technologies. So, but before reaching to them to know about the quantum science and technology, we must, our teachers community as well as our science communicators has to be first addressed to know the subject matter first, so that we can reach to the mass people as well as to the grassroots level. As Dr. Tagi has been mentioning that first of all it is the making them understand this emerging field of science and technology, about quantum science and technology. So, in my opinion, I think that we should first energize our science communicators, as well as bring our science communicators, as well as bringing awareness will be the pivotal role to make this emerging science and technology make understand at the grassroots level. Thank you so much.
Dr. Singh, I just want to add one more point here, because there is one very big challenge what we have in India is about the what kind of the language we should adopt. Because if we look at constitutionally, we have 22 languages, officially recognized languages, and more than 4,000 local dialects. So forget about the school-going population or which are the part of the formal education system. There is still a chunk of population which is left out. And we need to communicate about this science to them also. So now the challenge is how to communicate with them. Which is the language we should adopt. To what extent we have to be, the culturally sensitive to their belief system. Because all the marginalized society and tribal society, because I have worked with him, I have seen, because recently we did one compilation on traditional knowledge system of different tribes of Arunachal Pradesh, and I think it was 8 and 9 dialect. Some of them were using the Bangla, some of them was using the Roman script for their dialect because they don't have the script for their language. So how to communicate? So that's why I'm saying that we need to design our communication strategies in such a way that the penetration should be at the grassroots level, especially to those who are not covered by the mass media, because many places there is no electricity, there is no internet connectivity, and only thing is like using the traditional mode of communication, like the puppet which we have seen in the morning. But for that we need a trained resource person, the person who has the understanding in that medium and in that subject. So for training is to be, the program needs to be divided. So it's a long way to go, but we have to start it. Whatever has been built up, because two people, or can say the great personality of science communication are sitting here, Dr. Patelia and Dr. Kamle, who has did a lot into the science communication, and whatever they have built up, we have our, the resource person, trained journalist almost in all part of the country, but still that remain confined to only those 22 languages. So we need to penetrate further if we want to take the benefit of this science to the entire population. Otherwise it will remain an elite science.
In fact, we cannot ignore the role of non-governmental organization. In fact, I understand many places that group of people really accommodating and adopting the scientific concept and really taking it to the people. I think that role also should be remembered. The non-governmental organizations in our country are playing greatest role in science communication. I think the science communicator can use them more. As Sir said, so many languages is there, but we cannot conflict with that. But how we can really reach out to the people through non-governmental organization, I think their role is laudable, and we should remember that also. Thank you.
Just on the very lighter side, there is you can realize the gravity of, because for scientific terminology, there is no standardized, the format in different language. In Gujarati, whatever is a Parmanu is a Anu. In Northern Indian, Hindi state. And what is Anu, it is a Parmanu in Gujarat. So this kind of variation in the language, even if some communicator is trained, he need to be sensitized toward these kinds of issues also. Yeah.
Thank you very much, Professor Vincent, as well as Professor Gaki. Is there any question for our third speaker? Yes, sir, please proceed.
Yeah, my question is to Dr. Devajit. This is Professor Saibaba. I think when we're discussing about communicating science, when you said about so many dialects which are there in your state, in Arunachal Pradesh, and which do not have scripture is there. So my question to you is, how do we communicate? Second thing is, do we have to communicate everything to them? Everything to everyone? Is it a need-based awareness is important rather than bringing everything to everyone? I mean, I thought this is, when you were discussing about the diversity, it occurred to me, maybe we are doing a mistake by trying to communicate everything to everyone. I thought you comments on that.
Yeah, so regarding this communications, you have rightly said that we don't have any dialects that I can say a script where that means now in Arunachal Pradesh, this Hindi and English are more relevant. Every people understands. At a rural level also Hindi is spoken because Hindi is like a second mother language there. Because we have a CBSE system of education there in Arunachal Pradesh. And right now, this you're having without any that means script for the dialects. We have adopted this Roman script to that means to translate all the things as per from English or Hindi to their dialects. So that means your second part of the question is that if we have to communicate everything to the everyone. So I think that whatever science that means like this your quantum science and technology and other science, emerging science and technology, that means we have a definite target group has to be taken. Maybe the rural populace may not be in a very need of this technology to understand this technology, but they have to understand because now in every nook and corner your internet plus maybe in some of the part they may not be in connectivity, but everybody has their own your mobile phones because it is also I think that is they are well communicated. That's why first of all we should target first target group like students community as well as teachers community to make them understand what this emerging science and technology is all about.
Thank you. I have a couple of comments here. See, we were talking about the medium of instruction. We have about 22 languages in India, like you said, and more 1,000 dialects. Well, that is true. And but I would like to mention one thing. That I mean say, just translating, I mean say now whatever literature is available into the local language doesn't really help. I know there was, I mean say, once a move in Gujarat, that's a very, I mean say, there were hardly any Gujarati people. So they started translating, I mean say, most of the well-known, I mean say, textbooks in English on science and technology into Gujarati. And the translation was so terrible that you could never understand Gujarati. Even the one who is a Gujarati speaking person or a native of Gujarat could not understand that language. I'm telling you from my personal experience, you see. While in Delhi, the Gyan Prasad, so we used to come out with one scientific, this popular science magazine, so anyway, and that was a bilingual magazine, both in say, English and Hindi. English was no problem, but when it came to Hindi, we could not find even a handful of people who could translate the English articles into readable Hindi. I mean, a country which has a population of something like more than 45, 50 lakh Hindi-speaking people, we could not get even 10, 15 people who could translate everything properly in, say, Hindi. Well, this is a problem in most of the, say, local languages in India. So that's one thing. We need to, I would say, translate into a language, say, which can be understood like Tajik. Tajik for children, the language has to be different. For grown-ups, the college students and university teacher students, the language has to be proper. Well, and for the general community, again, it's good. We don't have that kind of. First thing is we need to develop this kind of, number one. Next is that, as I said, even if you have people who can translate well, I will say now from English language, he himself has to understand science. It's not that he only has to know only English and Hindi or English and Marathi or English and Bengali. Okay. The thing is that he has to, so he himself, I will say, needs to understand science. He has to have a fairly good grounding in science, in any subject. He has to understand science. And then the sense of science has to come from English article to the local language. This doesn't happen. That's the problem. If you go to tribal areas, like Devajit talks about Arunachal Pradesh, there are so many dialects. You just can't help it. This the Hindi or Gujarati which we use here, it just cannot be read in the tribal bit. It just can't. What do you do? So now I will say, these are real questions. The other questions is that, say now, well, we should answer both articles. We are only reading about some sort of awareness, some sort of information you are passing. Okay, that doesn't solve it. Okay, passing or giving information also, what is now quantum science, and to bring so those concepts at school level, it will never solve the problem. The reason is this, that I will say quite often, say now, to understand some certain concepts, you also read certain levels of complexity. We don't understand. We think that more understanding, more I will say now, what I will say approach is have more of I will say modern information which is scientifically available. That's not the case. Next. What is important is that there's some sort of interaction with these students and teachers and all that. What interaction do we have with students? Only the teacher who has, who teaches in the class, and that too is a very prosaic factor. Is that the only interaction? When we talk about science communicators ourselves, most of our efforts are limited to bringing out some publications for popular science. Or some films, but there again now this is more towards information. Okay. What is missing is the spirit of science. Okay. How do you bring it to the spirit of science? Or spirit of inquiry, method of science? How do you do it? That's only possible through interaction. So this is really necessary. That our efforts are more directed towards without developing this spirit of science or inculcating science, so-called scientific paper. And then I really don't want to go more into it. But that if we along with information, we also have to now put in real efforts so that we can pass on the spirit of inquiry to children. Let children select whatever their subject of their liking. Then we don't have any hold over. They will select something, any subject of their liking, and let them work on it. Finally, it's all left to an individual to study, to develop the method of study and all that. But we only have to show them the way. Can we develop? Can we inculcate a spirit of inquiry into this? If we do that, I think half of our job is done. I think that the Nobel Prizes will come when that happens, you see. It's not by that translating books into Tamil or Gujarati or Marathi. Okay. So I think this is what is really necessary. I think I can go on talking several things about this, but I will stop.
Good afternoon. We represent Director of Technical Education here. It was a wonderful session. Sir, Mantaji, you mentioned about science communicator has to be trained first. So how you see the capacity building of teachers or professors and how you envisage at your level for capacity building so that the quantum science and technology are percolated to students well? That is the question to you. Second question which I wanted to ask to Dr. Vincent. He said that in Tamil Nadu you already made a compulsory subject on quantum science and technology. What is your experience by implementing this subject to all the students of engineering? So we also cater engineering education here. So that's why I wanted to know your experience and vision. And third aspect which I wanted to ask from Tyagiji, he mentioned something from, and even from the booklet which I read, he touched upon the Indian knowledge system, basically the Vedanta, which was touched upon by him, where I see the Kanar at the first place. And I just wanted to know how Advait, Vedanta and the quantum
is related, or is there any analogy which you think about? Because inspirations are taken from anywhere. Of course, in a way, it is more of a self-realization, but in the physical world or in the science world, we have to prove something there. So are we going on that direction also of our ancient philosophy? So all three questions which to a different panelists I wanted to ask.
Thank you so much for asking this question. According to me, it's a very big success story in Tamil Nadu. See, our CM started one scheme called Non-Mudalgan. That scheme is the reason to revolutionize all the process. When you define the Non-Mudalgan scheme, see, almost all the students who are studying in higher education, they're supposed to undergo the various training process, and including there is a component for UPSC and your own our GATE exam and all this. But in terms of personality development, so many almost 1,000 type of program is provided to the student. Though it's called a compulsory process, but it's well designed and provided to the student community with trained people, because it's not simply given. This one. With reference to this quantum science in engineering college, made it compulsory after thorough analysis and the training program which rendered to a group of faculty member in the engineering college by the Tamil Nadu Higher Education Council. You have a separate, of course, Gujarat also will have that. The Higher Education Council taken that responsibility. Then, with the help of them, this curriculum got developed. Now it's working well into that. And also, as you know that, Tamil Nadu also into the process of quantum science as well as semiconductor. So somewhere we are connecting quantum, AI and semiconductor, and then for which we need a trained human resource. This is one of such a triangle model which working very well in Tamil Nadu. That is what I said, successful story. Thank you.
The last question, this is something I think recently this film Oppenheimer, you might have seen that film. So what was the basic premise of that? He was able to break the atom, and then he realized that he has given such an immense power of human destruction. Okay? Now this was bothering him. This was a mistake on mine. As a scientist, he was regretting. And he was restless. So where he find the peace? In Bhagavad Gita, when he said ki you are only a karta. So then he realized then it was a wish of the God. Then only he got bit, sloth in his, otherwise he would have gone mad. Similarly, there is one more book by a very young theoretical physicist, I think Day-1, Shiva to Schrodinger. I think it is available on the Amazon, that book. He has compared the Shiva philosophy. The Schrodinger has, it is a parallel. It is again an inspiration, not a ready-made idea. Okay? The principle of uncertainty. So that means when your thinking process comes to a dead end, most of the Western philosophers, because many of those things are now available in their language, or even Oppenheimer learned Sanskrit to read the Bhagavad Gita in original. Okay, so when many times, because theoretical physics is basically is based on some physical premise, where you are searching for a possible solution or some parallels. And India being the oldest civilization, our rishis, our munis has given, they have given, they have thought about every possible situation. I feel so proud of that being an Indian, that कहीं ना कहीं हमें वो reference मिल जाता है जहाँ आप फंसे होते हो. So most of those things, which the parallel which they have drawn, over which they have built up their own theory, which they finally tested. So there is no direct lift over. It is always a source of inspiration, which they search in Indian system only. Yeah, abhi bhi hai, because if you go to Europe, Germany, this was my personal experience. He developed that जो हमारा यज्ञ करने का वेदी होता है, उसकी ज्योमेट्री के बेस पे उसने एक स्ट्रक्चर बनाया, and all the content which we are using doing this yagna, वो उसने वो रेडीमेड किट डेवलप कर दिया उसका, and he is selling it, and he has a scientific report to which I have my own reservation. He proved many of those things which the belief system which we have in India. So it's like that. We had some way out wherever you are. can say कि जहाँ फंस गए हो, रास्ता नहीं मिल रहा है, तो हमारे पास वो है जो थोड़ा आपको रास्ता दिखा देता है. Even that is true to the science also. But as a scientist, we have to be very very clear कि वो direct lift over नहीं. It's an inspiration. It is a parallel drawn way on which he has proved it scientifically, which is accepted to the scientific community.
Yeah, regarding your capacity building, just I'll talk about Arunachal Pradesh. So we have only 2 universities and only 2 engineering colleges and 225 secondary schools having class 2 science stream. So drawing, that means your science communicators among the teachers has been challenging. But what I feel that to be a science communicator, one should have that inner, that means responsibility towards the society in which they live, so that they can also communicate whatever they have learned to the younger generations.
Thank you so much, all the respected panelists, for a wonderful talk, wonderful suggestions, ideas, and in future what we can do, and now where we are, you've been really very nicely put forward, and even the participants, very nice questions, and some of you have also given the suggestions also. We really appreciate, and this session has been quite interactive. With this, in summary, I would like to put forward in front of you all that this quantum science, it has become a science how the universe works at the tiniest scales of atoms, electrons, protons, revealing a worldwide particles act weirdly being waves and particles or existing superposition governed by probabilities, not certainties, as the speakers have already said, forming the basis of modern technology like lasers, transistors, and quantum computing, MRI, quantum imaging, including artificial intelligence and machine learning incorporation. So in this also, our respected speaker has also clarified that though artificial intelligence and machine learning is coming in this present scenario, however, we humans has to really understand what is behind the quantum science and has to put forward the correct data input so the artificial intelligence and machine learning can be correct in future. Hopefully, humans do not have to suffer in the future with this. And quantum science, though there is ideas accessible to everyone, multifaceted, approach using relatable analogies, providing hands-on experiences and interactive tools, and connecting abstract concepts to real-world applications. And we have already learned that from science we come to know that molecules, atoms, nucleus, electrons, and further broken down to protons, neutrons, and subatomic particles, further breaking down to quarks, leptons, bosons, and elementary particles. With this, I would like to add a little bit of philosophical from Sanatan also, which Professor Tyagi has also added already. From Shiva's philosophical here, we add that Atma, we all know soul. We say that there is Atma in all the human beings and all living planets, in like one health system, in plants, in animals, and humans. And right now, we, most of the scientists, we are not being able to find out what it is exactly. And we believe from Sanatan that this is also a kind of energy, a very minute particle that can be studied. But, however, as we already know that to learn these minute particles, it needs a lot of energy, lot of heat, a lot of sound. So which might, in future, if science goes ahead, if human, they dwell in this, even Earth and universe can be destroyed. So with this, research and higher education is needed. Contribute to newer quantum technologies is needed, no doubt. And we all human has to work on the direction of quantum science as a game changer in the science to the present world, but however taking care of the adverse effect of it also. And with this, I also would like to add few points what our respected speaker, Professor Vincent, has put forward, that quantum science has to be popularized, obviously, but for the positive sense. And there should be some examples as a successful story of COVID-19 vaccine for the popularization, and there should be outreach programs. And again, as Professor Dr. Brinda Kumar Tyagi says, over-expectation should, so not to destroy our world where we live. And again, there is philosophical logics are there which can convert to tangible proof to make understand this quantum science. And obviously there is a challenge ahead. And with this again, according to our third speaker, Professor Dr. Debajit Mahanta, that there should be a teaching of necessity of quantum science which can be also taken as a role model, pick up, and there should be a needful work to be identified as a work, as a pivotal role for quantum quantum science to go ahead and understand, to bring to the layman level. With this, I would like to thank the GUJCOST and also Professor Pataria for inviting me and with the support, and as well as all the respected speakers as well as respected participants for your valuable time and listening. With this, I would like to adjourn this session here. Thank you so much.
Thank you to the chair and all the panelists for an enriching discussion. Now I would like to request the chair, Professor Anjana Singh, Nepal Academy of Science and Technology, Kathmandu, to kindly felicitate our esteemed panelists on the dais. Starting with Professor S. Vincent, Member Secretary, Tamil Nadu State Council for Science and Technology. Professor B.K. Tyagi, former Director, Vigyan Prasar, Delhi. Dr. Devjit Mahanta, Joint Director, Arunachal Pradesh State Council for Science and Technology. I would like to invite Dr. Narottam Sahu, Advisor, GUJCOST, to felicitate Professor Anjana Singh, Nepal Academy of Science and Technology, Kathmandu.
Thank you, everyone. We now proceed to an expert talk to be delivered in virtual mode. It is our privilege to invite Dr. S.K. Varshney, former advisor, Department of Science and Technology, Government of India. Dr. Varshney is a distinguished science facilitator and policy expert with over 3 decades of experience in promoting research and strengthening scientific collaborations. We are honored to have him address us today. Now I request Dr. Varshney to start with the session. We welcome you, sir.
Thank you very much, friends. And I would be speaking, just 1 minute. You can see my presentations?
Yes, sir, it's visible.
Okay. So friends, I'm happy to be with you as a part of GUJCOST activity, and my thanks to GUJCOST for the same. And as we all know that 2025 has been declared by United Nations as Year of Quantum Science and Technology. And this was done in June 2024 to mark discovery of quantum mechanics foundations, which was done in 100 years ago. And UNESCO is the lead agency with American Physical Society. And focus has been to give on quantum research, building of ecosystem, governance, and standards, as well as international partnerships. So if we look at the key themes, what we are looking for is, one is that UN wishes that quantum be converted from theory to practice. So idea is how we can take experimental quantum technologies to critical applications, including hybrid quantum systems. Also, we would like the industry and artificial intelligence integration to be done in this period. To several fields like quantum computing, sensors, and communications are set to revolutionize artificial intelligence, drug discovery, material science, climate modeling, cybersecurity, or several fields. So it's not limited. Just to give you an example how quantum intelligence will play a role. Security is, of course, a major concern. So we are looking for post-quantum cryptography, how various threats could be handled, and how we can provide quantum solutions. And then, of course, the biggest challenge globally, if we see, is bridging the quantum divide. You know, when we are talking about our own country, we are talking about digital divide, urban-rural divide. So quantum divide is another thing which is coming. And efforts are now underway to address disparity, building infrastructures, and also to ensure equitable access to quantum benefits, especially in developing nations. And of course, how it will be done, it is by creating a new human resources. So a lot of emphasis is being given on workforce and education. So what we are looking for is we need to create a lot of quantum workforce and mobilize education to growing demand. So we need to reorient our students who are now looking for AI, who are now looking for traditional courses, that if they could focus on quantum subjects, that would be really key things. So if we look at international development, of course, UN has declared it the year of quantum, and large regional efforts have been made. For example, European Union quantum flagship.
ચાલુ તો આવતું નહીં રેકોર્ડિંગ બંધ કરો હા
I think due to some technical glitch, okay, sir is back. We are trying to
sensors. And sensors measure quantum effects like particles passing through walls at the largest extent during the day for this. So if we look at this Nobel Prize, so we can understand that it has a major breakthrough. It has impact on computing, and in computing world it relates to quantum computers, quantum sensors, STM and flash memory. Another drive which UN has taken is quantum literacy. So quantum literacy is the ability to understand and apply concepts in quantum mechanics and quantum computing, moving beyond physical logic to grasp new paradigm for problem solving, innovating and navigating emerging technology crucial for future workforce, readiness, science, technology and economy. It involves understanding ideas like superposition and entanglement to leverage quantum principles for advancement in medicine, cybersecurity and artificial intelligence, making complex ideas accessible to everyone. The key aspects are we are looking for that conceptual understanding should be there, problem solving should be there, and technological application should be more evident, and they should be accessible. So how it is being developed? There are several e-platforms which are being used for e-learning tools and micro-credentials that are making the concept accessible, the curriculum integration to various things, and then also industrial and government participation in this. And then we have got superconducting qubits. These are leading technology for building quantum computers utilizing superconducting circuits to process information. These artificial atoms are typically made up of materials like aluminum and gallium on silicon substrate and operate in ultra-low temperature, which is let us say 10 to 20 microkelvin inside dilution refrigerants. And then we have got quantum sensing and clocks, and these clocks can be fabricated. Quantum sensing clocks, the principle of quantum mechanics are based on quantum principles like superpositions and entanglement in measuring physical quantities and unprecedented precision and sensitivities, while quantum clocks are advanced from atomic clock that uses atomic conditions for extremely accurate timekeeping. Both technologies offer specific advantage over classical counterparts and have a wide range of applications. As far as Indian development is concerned, India has created a roadmap on transforming India into leading quantum-powered economy launched by Niti Aayog. Quantum is not just another sector in innovation, it is now finding a basic tools for artificial intelligence, biotechnology,
sir, I would just like to
secure digital infrastructures. Global competition is intensifying.
Sir,
and so
sorry to interrupt you. Can you just
reach technical standard and build secure value chains? And roadmap underscores the need to expand our research infrastructure.
Hello?
Innovation into market pathway.
Hello, sorry to interrupt you, sir. Like your PPT is not visible.
Introducing high precision compute diode, high performance precision integrated laser is designed for quantum research, simplicity of operations, and in particular laser will to financial and banking industries to provide quantum safe transactions, providing sensitive and critical information. The next goal which world is aiming for is quantum as a service, increase the adoption of quantum computing, zero-cost computing, and AI-driven quantum. With this, I would like to close this talk.
Sir,
thank you very much.
Sir, can you reshare your slides?
Beg your pardon?
Sir, can you share your slides once again?
Yeah, I will share. I can put it on your WhatsApp.
Okay, sir.
Someone who would like to ask something?
No, sir. Actually, your slides were not visible, so I was just saying that if you could share your slides on the screen.
So I have shared my slides on your WhatsApp.
Okay, sir. So I'll share it with all the dignitaries. No issues.
Yeah. Thank you.
Yeah. Thank you, sir. So thank you for the entire talk and your time. And
Okay.
Yeah, thank you, sir.
express our gratitude to sir. Now, I kindly request everyone to kindly be seated as tea will be served at your places. And now, as we are running out of time, we will like to continue with our next expert talk. We now invite Mr. Tariq Badal, formerly Controller of Stores and Purchase CSIR, to deliver an expert talk. We welcome you, sir. Mr. Tariq Badal brings rich administrative and institutional experience from his long and distinguished association with the Council of Scientific and Industrial Research, Government of India. Yes, sir. We welcome you, sir. Now I request you to kindly address the audience.
सभी को नमस्ते, गुड आफ्टरनून। मेरा सौभाग्य है कि मैं यहाँ गुजकोस्ट में, गुजरात साइंस सिटी में मैं पुनः यहाँ पर मैं हाजिर हुआ हूँ। मैं पिछले कई प्रोग्राम्स यहाँ अटेंड किए हैं और गुजकोस्ट में खासतौर से डॉक्टर नरोत्तम साहू साहब और डॉक्टर मनोज पटेलिया, जो हमारे बहुत अच्छे मित्र भी कह सकते हैं और ये भी कह सकते हैं कि ये लोग जो है लीडर्स हैं साइंस कम्युनिकेशन के, और इसमें जो उन्होंने काम किया है वो बहुत ज़बरदस्त काम किया है। तो मेरे आज का जो छोटा सा मेरा टॉक है, इसे एक्सपर्ट टॉक कहेंगे लेकिन कहा गया है, लेकिन मैं एक्सपर्ट नहीं कहूँगा अपने आप को। मैं कहूँगा मैं ग्रास रूट लेवल का एक व्यक्ति हूँ जो कि चीज़ों को समझ के अपने तरीके से उसको समझने की कोशिश कर रहा हूँ। Can I have this next slide, please? Do you have a early slide? So the topic of my brief talk is next slide. Exploiting quantum science and technology for environmental sustainability, opportunities, challenges and public understanding. जो हम सुबह से बात कर रहे हैं, मेरा आपने काफी काम आसान कर दिया. My previous speakers have already taken a lot of issues which I am supposed to cover, but I am going to focus on the environmental sustainability aspect and how. So environmental sustainability, what we mean, what is meant is using natural resources responsibly to meet the present needs without harming the ability for future generations to meet their own requirements. And it is focused on balancing human activities within nature's capacity. Nature's capacity to regenerate needs time. If we do too much of exploitation of natural resources, the regeneration will not happen in the desired time, and that will create havoc. And we cannot eat without any biomass. We cannot eat stones, we cannot eat dust, we cannot eat other things. For human survival, we need biomass, food, energy. And if we destroy all these things, we are not going to survive. So ecosystems we have to protect. And ecosystems not only natural resources, water is also there, forest cover is there, we have biodiversity, we have wildlife, we have complete life cycle of these biological things. And to protect these things, we have to shift to renewable sources like solar, wind and tidal energy in developing area. And it's about maintaining ecological balance, ensuring clean air, clean water, fertile lands and mitigating climate change impacts. forms should suffer. Destroying forest, wildlife covers, natural resources, polluting them. It is really, we should have an empathy towards the other life forms, which we are missing in our own, need and greed. So it's our human responsibility to save other species, and there are different campaignings for different species, like this is a Save Tiger campaigning. I must tell you that all the photographs except one photograph of a scientist, it's all my own photographs taken by me while I am a wildlife enthusiast and I am environmental concerned about environment and ecology. So habitat loss is resulting survival of species. Wherever the habitat loss is there, the species are going to extinct, and we know there are statistics available that not species means you see the big species, there are microorganisms, they are vanishing from Earth, and that again creating a lot of issues between. Now, forest cover loss means overland depletion and extinction of biodiversity. So, if we have good forest health, good natural resources available, we can say that we are in a good environment and ecological balance is maintained. If this kind of a tree is cut, you will always see that thousands of life forms are dependent upon them. Either they are birds or they are insects or maybe other flora and fauna. Loss of insects and microorganisms results into crop failures also because there is no pollination and there are other issues. Now biodiversity hotspots are shrinking, affecting regeneration of invaluable herbs and shrubs. This photograph taken by me is Patalkot Valley in Madhya Pradesh. This valley is home of very invaluable herbs. बहुत सी जड़ी बूटियां जो हैं यहाँ पे पाई जाती हैं, जो कि invaluable हैं और कहीं और नहीं होती. This kind of hotspots they are being destroyed, then we are going to lose those valuable inputs from the nature, and lot of these herbs which are available specifically in this place are used in cancer treatment and other drugs. So that the source, if we cut off the source, like the golden goose story you have heard, so in that kind of exploitation situation, we will cut the goose and there will be no eggs later on. So it's like that. The forest dwellers have their own survival issues. Illegal exploitation of natural resources is in remote areas both unattended at times. You might be wondering why I am talking about all those things when we have to. My topic is quantum. So let us come back to that. Now the forest dwellers have their own survival issues. They have to survive. They have to depend upon natural resources. But for their own needs, they have to play with the nature. So birds are also important into life cycle and biodiversity. Their extinction is alarming. I don't know if some of you are bird watchers amongst us. I am also a bird watcher, a novice one. But bird watching as a hobby is one, and bird watching as a citizen science initiative is another issue, where through the bird counts, availability of different species in different regions, we can access this climate change situation, how it is happening and what could be, how can we do better out of it. Just for your information, in Delhi there is a bird atlas is being prepared, and 1 year is over. I am part of that. It's a 3-year project, specifically for Delhi. So this, we are doing it and studying the birds' behavior, their bird count. They are coming back to the same place at the same season. This all gives you, it's a big data collection which will, address to the climate change issues. And there is a, Border University initiative is there in that. It's an international project, in fact, where this bird count, there is a software. You feed anybody, you can also feed your data in that bird count things of your own place, giving that date and time and what species you have seen, and is going to be something addressing very much into the situation. Now, quantum science and technology, since morning we are discussing, I am not going to tell much, but it is the superposition of qubits. It can exist in multiple states at once. अभी मैं यहाँ खड़ा हूँ और अभी मैं वहाँ भी खड़ा हूँ. So the same thing is there, and these qubits, when they are connected, they can affect each other. So why it is powerful? Because the quantum science we are talking is speed. That is the speed. Quantum computers can solve problems. We have discussed many things in that because of the speed. And that speed is like that in real time. And I must say that in future times, it covers them. So that is important. Then we have different impacts on this quantum technology. Encryption is there for quantum computers, drug discovery, and so on and so forth. Now, this photo is not mine, it's from the internet. It is among stalwarts of quantum physics. Everyone from India was one who gave this dual nature, theory. Now, why I have put this thing? It was very interesting that some 30 years ago, we are having 100 years of quantum physics. It was in 1996 when we have celebrated 70 years of quantum Schrödinger's wave mechanics by CSIR, where the daughter of Schrödinger was invited as chief guest, and I was lucky to interact with her and see the personal papers of Professor Schrödinger. A lot of stories that she told in person to me. She is no more now. She invited me to come to Vienna. In Salzburg, where she lives, in a village called So, Schrödinger was very much, he was influenced with the Indian Vedanta and all these scriptures and, spiritual things. And there is another center for science, fundamentals of science and spirituality is there in Delhi, which covers all these aspects. Recently, this president has known Dr. Ranjit Nair, who was another physicist. Physics being my own subject, I am much concerned about that. And what as Mr. Tyagi also mentioned about the physicists, a lot of physicists were there in this conference which was done in December, just 30 years ago, in December 1996 in Delhi. And one Professor E. Sudarshan, maybe Professor Sai Baba must be knowing about, he was the person who was unifying this Vedanta and the physics. And he was denied he was an Indian origin scientist, he was a physicist, he was denied Nobel twice. Whereas the work he has done in association with other scientists, that is another thing. He could, other person got the Nobel Prize. I would not name him, but that is another thing. Now, we talk about public understanding. Without dissemination of our achievements, we can't, engage the general public in our, this kind of discourses. So, that was, again, this picture was taken on 11th May 1999 at New Delhi. Professor Mullimala Joshi was the Minister of Science and Technology at that time. Dr. R. Mashelkar, you can see is there. And on the other side, there are other science secretaries are there. And there were 3 events on the same day. And I'm lucky to be associated with them. I can be seen here on the extreme right of my listening. So it was the first time that we have celebrated nationally our own achievements in public. And that is very important to have this kind of, awareness, dissemination, that I'm feeling proud of it. That we have, so it was Pokhran 2 and then other missile and then 3 events were there, combined, but I was the honor to invite Professor APJ Abdul Kalam in person to attend this event. So that was the initiative taken by, at that time, by CSIR and other entities to start this National Technology Day. Now we are, BSc, TDB is doing it every year. Now public awareness and understanding are crucial for responsible development. It is important. The grassroots level person on ground, public should be informed about what is happening, and they have a lot of, aspirations. They have a lot of, excitement about new technologies. Like if we are using now mobile, you can see with mobile technology, even a street dweller, they are using AI. They don't know about AI. They are using AI. Now with this quantum thing, when their quantum mobiles will be there, very high speed things, then they will be using it, but without knowing the science behind it. So it is should be our endeavor to tell the people, to the public, what is the science behind it, how it works, and because as a taxpayer, public funds, user of public fund, government should also update them. So it is our joint responsibility towards our citizens to update it, and we have a dialogue with the public. This kind of forums which can be disseminated and further percolate to the lowest of the level. And we have to see that which kind of technologies we can use, which kind of technologies we should, not put into public domain because of their restrictive nature, like defense and all. Now, what are the opportunities having use of quantum technologies? This is key applications which are of futuristic nature. They are already going on, and it is a challenge to our young generation who are going to be more, involved in this kind of situation. That carbon capture and storage. Then we have environmental monitoring. Very important point. How I will just discuss how we are going to use this quantum technologies for this sustainable materials, quantum computing designs, eco-friendly materials, reducing reliance on harmful substances. That is also very important. And water sustainability is another area where quantum dot-based sensors, I think it was discussed about sensors earlier, monitor water quality and quantum optimizes irrigation system. These are all real-time monitorings are required, because if some harm is done, then we have to see the remedial measures. But forecasting before it harms is important, and that is the main purpose of quantum technology. But futuristic approach, not even in real time, it gives you a future warning after say this much time this is going to happen, that water is going to be contaminated like this. So that kind of technologies which are of a futuristic approach, early warning like tsunami, seismic AI-powered monitoring. Now, AI is integrated with quantum. AI is a different area, quantum is a different area. Now, combining them, AI with quantum, it's a good, solution for monitoring. AI cameras, sensor track, endangered species, detect, poaching and monitoring, monitor habitats, drone and satellite, high resolution imagery will help monitor wildlife population, habitat changes and illegal activities. Means it will give warning before it happens. So you can stop that kind of a disaster. Then acoustic sensors can listen to animal noise to track species and detect threats. Wildlife and microorganisms, they emit lot of waves which are not in the hearing range. That can be captured through quantum technologies, use of quantum. Then DNA tracking is there to analyze environmental DNA to monitor species. Quantum sensors, as I mentioned earlier, that ultra-sensitive sensors detect tiny changes in ecosystem. We come to the studies, after years of studies, we come that this change has happened. But with the advent of quantum technologies and quantum science, we can measure not even in real time, as I mentioned, before it happens. That is the beauty of quantum. Cat is dead and cat is alive. So like that, we have to capture these details as early as possible so that before it harms to the planet, we are coming up with the solutions and all that. So that is a very complex situation, but I think we will be able to do it in this thing. The public awareness. Now, so public awareness and understanding are crucial for this development of adoption of quantum technologies. Growing awareness, survey indicates high public awareness on terms of quantum technology. लोगों को quantum word पता चलना शुरू हो गया, but they don't appreciate what kind of science is behind. So that has to be told to them. Then public optimism is there, need for engagement. I have discussed earlier, responsible innovation. Again, experts exhorted for an approach that emphasizes sustainability as a core. So sustainability is the core, which is the main focus on my talk, that it should be sustainable. And sustainability comes with austerity also. We have to limit our consumption of all these natural resources, including water, including other things. So it is going other side. Now challenges for technology development. Qubits are, as just discussed earlier, earlier speaker was there, that need to be super cold and isolated to work properly. So qubits, those materials, we have to develop technologies, superconductivity, and to keep those qubits working. And that is the challenge. That is the challenge. And as in the summing of Professor Anjana Singh has mentioned about that this is going to be the challenge, and which needs lot of energy. Now again, to do something through quantum, we need lot of energy, and we want to save energy on the other side. So that is how this vicious cycle is to be cleared. So that is the renewable sources, which are solar, wind and tidal, and maybe geomagnetism and other things that can play into that energy without fossil fuels and without other harmful emissions and other technologies. We can use it. That is the challenge for that. And since quantum computing is special ways to fix errors, that is totally from classic computing is going to be different, totally different. It may crack all the present computing systems, and at the same time it may lock all other technologies. technologies also. So that is, is there. Sorry. Now, there are challenges before environmental sustainability, that habitat loss and fragmentation. We talk a lot of this about it. Out of views of young people, do you go to habitats? Do you go to forest? Do you go to wildlife? Or you stay in your home or your institute or in your cinema halls or your mobiles? I think very less number of people are going to actually see what is going on the ground level, which I request you to put some time of your to visit places. If you don't have time to go to far off places, at least visit your local park and see what is happening over there. We should be empathetic, not we should be apathetic. So we should change our apathetic behavior with the empathetic behavior, and only then we can make changes. And we see a lot of wildlife human conflicts are there. Why these are happening? These are happening because of different things, including climate change, increasing need for energy, pollution, and so many other things. So that is very important. And there are invasive species. They are going like lantana, and there are so many other species are there which are very harmful for the human health. Now, quantum technology, deploying the use of quantum technologies, they can detect these kind of small changes which takes years together to register. It can register in no time, these technologies, and that means futuristic approach. They will do the lot of modeling also, which will tell that this species is going to take over. So we have to take a preemptive action for that. Now, what is the way forward? Research is ongoing to make quantum computers and technology. We have discussed this thing. It is going on. People are working. A lot of schools are working. So many scientists are working on that. Then industries like finance, logistics, and pharma are already exploring deployment of these quantum technologies and applications. And challenge again, I am addressing the young people over there. Of course, their rights also. What are the challenges before young researchers, technologists, and innovators to come up with the cost-effective, green, and energy-efficient solutions? So that green is there for the environment, energy efficiency is again there for that, and environmentally sustainable quantum science and technology. So this we have to see. These are the new vistas where our young scientists, young researchers can look into from an environmental point of view, not only the economic point of view, but the social point of view also. And thank you very much for your patience. Let's you all come forward to protect our planet for future generations with smart quantum initiatives. Jai Hind, Jai Bharat, Jai Vigyan, Jai Anusandan, and Jai Quantum. Thank you very much. I can be contacted over my email over there. There is a disclaimer about the sources. Thank you very much. Thanks.
Thank you, sir. Now I would like to invite Professor Manoj Kumar Pataria, President International Science Writers Association, to felicitate Mr. Tariq Badr, formerly Controller of Stores and Purchase, Council of Scientific and Industrial Research.
If you have any questions, we can discuss, maybe take off the dash if there is a time constraint. Thank you.
Thank you, sir.
We now move on to one of the most engaging segments of the day, a hands-on demonstration session aimed specially for educators and students.
questions.
I would like to respectfully invite Dr. Narottam Sahu, Advisor GUJCOST, and Dr. V.V. Kamble, former Director Vigyan Prasad, to grace the occasion with their esteemed presence. Sir, I request you to please take your seats on the dais. Help me in extending a warm welcome with a big round of applause. Dr. Sahu and Dr. Kamble, we respectfully invite you to begin the session.
Good afternoon to everybody. I think this is the hands-on
part of this 2 days workshop. And before that, whatever the hands-on activities kit that has been indigenously designed on the quantum science technology outreach program. So it's a very unique kit. We have prepared it with the kind support and the guidance of Dr. B.B. Kavle sir, who was the former advisor of the Ministry of Science and Technology and the former director of a Vigyan Prasar also. And sir is also basically a physicist by profession and a science communicator by training and activities also. Designing the large big science outreach campaign like this one, it was a very passionate subject of Dr. B.B. Kavle sir. So after retirement also, he is that much active in this type of activities. And I think this initiative we have designed for 5,000 kit, and now we also asked for another 3,000 kit on for the special supplement as well as the special distribution also to the higher education and college students. And these kits, I think it has some 33 activities, hands-on activities, 3 different levels: pre-quantum area of understanding, quantum area, and now what we are going to be there. And who are the pioneers who have coined this quantum as a subject, word, and how the development has been going through. So, wonderful journey, wonderful hands-on experience. क्वांटम जो सब्जेक्ट है जिसके लिए एक्सपर्ट सब्जेक्ट लोगों को भी इनको कॉम्प्लिकेटेड समझते हैं एंड लोगों को डरा देते हैं कि ये कोई समझ नहीं सकते हैं. This is the key where you have to find that how best we can this thing. In fact, when we are prepared to discuss that kit, I was understanding my graduation and post-graduation time where we have get it by heart by what is that Heisenberg's uncertainty principles and what are the subsequent consequences of like that way. But this has been simply a 3D card, like whether that cat is alive or it is dead. Where you are be there in Gandhinagar or you are in this conference, where you are in the आपके ऑफिस में है और घर में है और यहाँ पे है, how these things are possible, and these are only possible that when we are believing that atom has that two particle character as well as wave character, so that type of understanding has been given by there. So I request Dr. Kavle sir to take you through this activity journey and give you that glimpse that how quantum you can touch it, feel it, and as Dr. Manoj Pataria sir has initiated that word in like that way, let us have this quantum thought, so that which will, like our imagination or our dream, it will be have that wings to reach at the scale or at the speed with the science. Thank you. Over to Dr. Kavle.
Thank you, Dr. Sam. Since morning we have been talking about the development of quantum science and technology, and we had a technical talk in the morning followed by a general talk on history of quantum mechanics and quantum technology. Now we also have been talking about how to communicate science and technology, and in particular, so how to communicate the ideas of quantum science and technology to the general public, to the kids, to the students, and anyone who is interested in this field. Now, I must tell you one thing, that people are inherently interested in science, but the point is that there are hardly any people, rather very few people, to answer their queries, to satisfy their curiosities. And that's the reason, say, we are the gulf between the science and the people of the is really increasing. Now, these are basically things. I have been in the field for almost, say, last 4 decades. And every time it's the same questions. Whenever I will say we have this talk and this, we have to communicate and this is some scientific topic. So how to do it? As I was saying, I will say some time back that it really depends on the target group to whom you want to communicate. Say in the proper language, let's say, and say in a way they understand. And then what's more important is that inculcating the spirit of science and the spirit of this questioning. It's not really what is important in answering the question, but it's really the questioning the answer, that's really more important. So, I mean, it's that spirit of questioning the answer, whatever explanation, whatever answer is given to somebody. What's really important is, I mean, to ask whether, I mean, whatever I have told, whatever answer I have given, whatever explanation I have given, is that true or not, or say, and so that you provoke him to think on his own, think further, and so that I mean, he is eventually satisfied. Well, I will say these are the kind of things we have been trying, I will say different means, media and modes for science communication. And but probably the most important and the most effective means is the direct interaction. And then I will say this direct interaction that really matters when it comes to science communication. I think, say, you have heard, I will say now, quite a lot about the science communication in general, so during our panel discussion here some time back. And so I really don't want to repeat that. And also, I will say, we have been running behind schedule, I will say quite a bit, almost 45 minutes. So I try to finish my presentation early. And you have been given one activity kit on quantum science and technology. And it's really an effort in this direction. Okay, the problem is that so when we talk about communicating science and technology, so when we want to communicate, how much do we ourselves understand the ideas of science, the quantum science and technology? That's really more important. And so if we understand the ideas better, then we can communicate those ideas also better. So I will say this is really an attempt in that direction. And what's more, I would like to tell you that not all ideas, not all phenomena have been considered in these activities. As Dr. Sahu told you that there are some 33 activities in this kit, but I must tell you beforehand that these are only a few representative activities, and some of the important activities probably we shall be considering in the next edition. Okay, so just to give a flavor of quantum science and technology, and I will to explain basic ideas at the most basic level. You see, that's a big idea. So, this kit really has been designed by two of my good old friends, Mr. Technology-GUJCOST and sorry. So I think I'm getting old, so I don't remember their names very easily. Anyway, so now I ask Technology-GUJCOST here. So now here is the young designer, and he and Ahmedabad, there's a father-son duo who has really designed that. So really appreciate whatever ideas which we have, and they have been translated into this kit, which we do hope will be useful and in communicating some of the basic ideas of quantum science and technology. Okay, so now to begin with, whenever we try to understand or try to learn, some of the scientific phenomena or scientific concept, will we really need to begin with how it all developed, how it all evolved. So I will say now, which means that we need to go into a bit of history of that particular phenomenon. Similar case is when we talk about quantum science and technology. Okay, so I would say if you want to understand some of the history, some of the historical aspects also need to be given. And then I mean, so how that phenomenon or say was discovered, that was we need to tell, and then finally, what is importance, what is its utility, what are its applications, and when we start when we explain, a particular phenomenon or a particular invention in this manner, that we can reach the people, we can make them appreciate, the importance of that phenomenon, discovery, or something like that. So that has been one attempt in developing this act. Okay. So I think so now we shall. I think we shall now go ahead with this. Now, this is the kit, I guess, which is in your hand, so that I really don't have to talk about it. Say, it has been divided into 4 parts, basically. Okay. Some of the before the quantum, we are really reading, before the quantum mechanics came into being. Then there is quantum mechanics, there is some of the applications, and there's the quantum technology, and there is a quantum computing into the future applications, possible future applications. So that's what it really contains. So I would say, and I think it also has, I would say, sorry. Does it listen? Does it have listen? Just screen or yeah, that's it. So I will say now this is the first section. There are about say 10 activities in this before the quantum, and it really taught the as I told you that we really need to tell them the children, and I must also tell you this particular kit is at the level of class 10. Okay, so which means some of the more important concepts or activities we have not really considered in this, but we shall be considering in the second edition. So this is so considering that level of students, we have not considered some ideas which you might think that should have been included, but they will be included in the next edition. Well, more than more than a century ago, so almost 125 years ago or so, the society consisted of such that it was thought that the essential business of science is really over, is really finished. And this was what the science taught John Townbridge. That's what he said. And the practitioners of classical physics, basically, they used to think that all the great discoveries that need to be made have already been made. And that now there is hardly anything to discover now. And if at all, if we have to discover anything, then we have to do measurements to greater and greater degree of accuracy. So surely it's true that some discovery did come, say, by very accurate measurements of some certain quantities, like say, the next decimal places, you see, of these constituents of air, say, when they made the measurement, that is how the element argon, gas argon was found. But then, that is what it is. And they thought the essential business of science is really over. But now, and that time, the in thing, which was really, being, practiced by scientists, physicists, that was the spectra mainly, because of this Bunsen and Kirchhoff. And this is really, these are different spectra. I'm not going into those, but I will be talking about it a little later. But then they're interested in different spectra. And that is how there are some applications to astrophysics also to that. But then it is this spectroscopy which was in infancy, which eventually, gave birth to this quantum theory and quantum mechanics. Well, so now here now there is to explain this spectra. What are those spectra? As I told you, if we are going, we have trying to put the activities in a historical perspective. So some of the activities before quantum mechanics, what was there? The so-called before the quantum mechanics came in. So we had I told you that's one particular thing was the spectra. And to understand the spectra, here is a simple activity. So let's which we have developed. And we will go ahead and say very fast. I don't want to show you all the activities because that will take much more time. So only some representative activities that we are going to show to you. And that too, I will say, you have a kit. You can, I will say, try yourself, I will say, at home or somewhere that you can go. I think my friend, I will say, Kathan, he will tell you all these, I will say, now, what we try to do in this particular activity of the city spectrum. So.
Okay. Namaste to all. Okay, so how we have developed all the material, everything comes flat in the kit. So we have a possibility to convert two-dimensional things to three-dimensional boxes. So that's the approach which we have taken. And so it's easy to post, it's easy to ship to all the places, and that's the approach which we have taken. So everything is color-coded. All the activities in the first segment, which sir has mentioned, is in orange color. So all the material which we can find in before science is in orange color. We'll find activity number 2. We have a small box. So if we just hold the box, and it would turn up to...
Okay, I'll interrupt you a bit. You see, I mean, now generally speaking, to see the spectra, we use either a prism or a diffraction grating. And but then you know that the diffraction gratings are obviously really expensive, and prisms are also expensive. So obviously what we made use of was a CD, and that is compact disc. And this which has those rooms, of course, is not as efficient as a diffraction grating, which has something like say 2,000 lines on its per inch. But then this has a CD has only about 600 to 700 lines per inch. So per centimeter. So which means I mean, this is a very crude type of grating, but it does work and it does work quite well. So that's what we have taken into consideration, and this is how the CD spectroscope was developed.
Okay, so in the plastic envelope we have the activity number 2, and basically once you fold the box, it would make a box which has a slide, which is a slit at the bottom. There is a slit at the bottom, and there is a hole in the front of it. In the plastic envelope. It's in the plastic.
There is a slot for the CD.
This is the CD. In the orange box, small box, which is something like this. This is the orange box. Inside that there is a CD. So you open the box from the front. It opens up to be like this, and inside this there is a CD. You'll find a CD inside this. You can take the CD from there. You assemble the box from the plastic pouch, and all you need to do, you need to insert the shining part of the CD inside this slit. So we have a small device which can be used to understand or have a look at the spectrum ready with us. What we need to do, this works as CD inserting groove. This area, there is a small slit on top of it, which acts as a slit to allow the light to enter. You are observing the CD from the front hole. There is a front hole to it. So what you need to do, you need to just observe. If this is the light, if this is the light, you are allowing the light to fall from the top on the small slit, and you are observing the CD through this particular hole. So we are able to see the spectrum of this particular light. So this is a very simple device which we can use to observe different spectrums. We can allow or prompt the children to observe different spectrums of different lights. May it be mercury light, may it be LED light, may it be the sunlight, or may it be a sodium light. So this is what we need to allow a child to observe.
In fact, I will say you should hold this almost 10 to 20 feet away from the source of light. For example, there is a mercury light here. So that if you look at it, you will be able to see the mercury lights, or say sodium light, or say if you see at least which is from the streets, you will be able to see the sodium, say the D lines, which is 550 or 556 angstroms, very well. So now, in this case, that's a very crude CD spectroscope. It does work, and it works very well. Only thing is that the CD, you should not look at the direct sun because it can, your eyes can be injured. Okay, we'll go to the next one.
Also, just to mention, there are illustrations on all the activities. Every single activity has illustrations along with the writing. So there is always a double confirmation.
So there is always, obviously, if something is to be done, so then complete instructions are given say, in the instruction sheets. Also, obviously, the basic information and also, obviously, some history and it's the importance of this particular this phenomenon that is also given here. And if you have to take any precautions, that also has been mentioned here. Now, next, obviously, the things in the 19th century, late 19th century, people were really, obviously, now worried about what the black body radiation. And of course, with attempts to explain the black body radiation theoretically, like the Relay and Jeans, they did it, they couldn't do it. But then, say now, that's why, obviously, now black body radiation, what happened? What happened? Now, black body, say by definition, is one which can absorb all radiation and can also radiates all the radiation itself. And its spectrum will depend on its temperature. So now the concept of black body as such is rather difficult, we say now at the school level. So that's why this particular activity has been made, and you see that I think you explained.
Okay. We can imagine a black body to be a hollow box. So we have a hollow box with us, and what we have done, that once we assemble this box, we allow a child or prompt a child. There is a hole in front of this box. There is a hole in front of this box. What we can prompt a child, the box has white interior. So we can allow a child to flash a light on top of this box. The light which enters inside this box, the child will basically see the white surface inside this box. When a child starts looking at the box, observing the hole, the child will basically be looking at the white surface inside the box. But when we close it won't work. It's a LED screen. It would work much better on the projector screen. But once you close the box, the real magic happens. If I am pointing the light inside this box, the light rays enter the box, but they do not come out because they are being absorbed inside the entire box.
Because of the multiple reflections, it really won't come out. So that small hole, that will look dark. So that really, this small box, it acts like a black body. So that's the idea of black body. We'll move to the next one. And see, I mean, see now, it really, the so-called modern physics, it really began, say, in 1895 with the discovery of X-rays by Röntgen. That was in 1895. And towards the end of the 19th century, soon after, I mean, say, there was the discovery of electrons by J.J. Thomson in 1897. And then, I mean, say, now, radioactivity by Day. So, I mean, so this was something, say, now, which had, people got busy with it, and they started questioning the basic ideas of classical physics, because these were the phenomena which were discovered, which did not directly follow the concepts or the laws of classical physics. And so that is where, I mean, the story really began. So now, I mean, to explain, I mean, now some of these ideas, say, now there are a few activities. If we are unable to give any specific activities, it really gives an information sheet along with, I mean, say, some experimental results which have been observed, say, now with that particular device. For example, this here is a activity card, say, which shows this some information about X-rays, how they are produced. And also, obviously, here we are showing that this is the, this is the very first X-ray, so it has an historic importance. Let's say of Rodgen's wife, her left hand, Rodgen's wife. So, obviously, you can see the ring also. When you read, obviously, this sort of things, the interest daily, obviously, increases. So now we will learn about, obviously, now X-ray. And there are, obviously, some experiments following that. But then, obviously, now, whenever there are some sheets which give some information, and not all sheets have an activity. Half of them, I think more than half of them, so they do have activity. So we will move to the next one. Now, similarly, with discovery of electrons. Say, it's very difficult to give an activity with electron. So, obviously, some information has been given, but and also atomic nucleus. There are obviously some references. So we have tried to maintain the continuity of this, the history, continuity of this historic development. And the next one is that. So we talk about 1901. The Planck came up with this Planck's theory and said to explain the black body radiation. See, and then that was really the starting point where we talked about the packets of energy. So he had to introduce these packets of energy, and so which means there's not light in a continuous manner, but a light which consists of quanta, or the packets of light or photons. Of course, the photon was given much later. And they are discrete. They can have only say discrete energy, so now, which is given by h nu, which is Planck's constant, and nu is the frequency. So either h nu or 2h nu or 3h nu or like that, but not as a fraction of that. So in any case, so there is a small activity for Planck's this thing for quanta. I think that will be up later. So it has some of these one sheet analysis views about the far-reaching implications of these discoveries of this 18th century. And about the board, I have given this only for the sake of continuity. And then next, after that, the important thing, important discovery that rather the advance in the theory that took place was the Morse model of the atom, who came up with this that there are some specific orbits, and where the electrons jump from one orbit to another orbit, and either when they jump to the higher orbit, they absorb the energy, when they drop to the lower orbit, they emit the energy. But in one, with whether delta E has to either H2 or like that. So to explain that, there has been a simple activity about electrons in an atom, and that is the orbits of the electrons.
So basically,
this is really a flip book, and if you turn it, so now you will see that the motion of the electrons in different orbits.
So we have a small flip book which shows the motion of the electrons. All we need to do is flip this book in an order. So I'm a lefty, so I need to hold the book in that hand. So we need to just flip the book so we can have a small animation in every child's hand. So we also should promote a child also to make their own understanding after observing this. We can also allow a child to grow their thoughts in this direction. Similarly, there is one more flip book, which is activity number 10, which is where is it? It's in this envelope. The flip book is in this envelope. So we have a second flip book, which is an activity number 10, which shows the electron jumping. So it shows the orbit jumping. So this is a small flip book which we are providing.
Okay, we move ahead. So quantum of energy. So now we have seen, let's say quantum energy in quantum theory. The energy is really discrete. It can be only in terms of steps. So either 1 or 2 or 3 or 4 quanta or like that. And then, so So but then say this continued almost up to almost 1923, 1924. So it was when Gujarat came up with this new nature of matter. That is his hypothesis that if this thing, and then of course I must tell you one thing that's now this photoelectric effect. I think I missed that slide. That's a yeah. So this photoelectric effect we have taken in this quantum technology, so we should be talking about it now. See, so now if so obviously now that matter waves, the matter can behave obviously like waves. So I would say now that was really something quite odd. So I would say now we have these waves. If this light is incident on some metal, okay, they can emit electrons. That's the so-called photoelectric effect. So that means I would say there is a light can behave like photons or say particles. Now if you say that's now if light can behave like particles, five particles cannot behave like waves. And that is how it all started. This was something like 1923. So now this is what it is. And after this followed, obviously Schrodinger's wave equation and this Heisenberg's thematic mechanics. So this was, and then also followed the role of uncertainty. So this is really quantum mechanics we had. So here there are something like about 9 to 10 activities again to transmit some of the important concepts of quantum mechanics. I think so far as the wave particle duality is concerned, I think so now we have, yeah. So now obviously now if you cannot talk about these wave particles, wave properties of particles, unless you also tell the students of the user of the kit about talk about some classical experiments, let's say now light waves. So now obviously there are some activities of this light waves which really pertain to classical physics, but they have a direct import into this quantum mechanics. And so some of the activities which are considered here, say this diffraction of light waves. After that, we could talk about diffraction of protons, diffraction of electrons. But if you want to talk about diffraction of electrons, you have to talk about diffraction of light also. And so obviously now this particular activity is given. So I can say you can explain this activity of how we have tried to do it.
Okay. I'm just going to explain this activity because it requires a dark room. We have two cards with us. I'll be taking this card which has an A and B marking on it. It has two slits cut out in that particular card. What we are doing, we are pointing a laser through the A slit, and in the second slit, what we are doing, we are cutting the slit by a human hair.
This is a strand of a hair.
So we are taking a strand of a hair and we are pasting in between the second number slit. So we are cutting the slit into two parts. Once we point the laser from the A slit, it would reach out to the second end to be 1 point. But if we point the laser through the second slit, which is a human hair, it would be diffracted. It would have the center part would have a thicker point. It would go darker. Again, the brightness would be seen. So a pattern would be created over there. So this is what the activity is.
You see the fringes there, see, and you can see beautiful patterns. You have to tie yourself just to the strand of hair with the sunlight, which also has been given in the text. Okay, you see beautiful fringes. So that's one thing. And if you have a piece of paper, make a small hole in that. and you shine laser light, you will get obviously this kind of circular pattern. Again, these are obviously diffraction fringes. So now these are these sort of things which children really enjoy doing it. They really, I mean, now they get so engrossed in that, and you only have to see and to believe it. Okay. So now this is one thing. So now this is really important. The next time you talk from here, then we from this diffraction of light, we talk about diffraction of electrons. And for that, I will say now we really don't have any activity. How can you talk about, I will show the electron diffraction? Yes, very simple. So I will say now there is a sheet there, diffraction grating sheet. And then, yes, we also have given a diffraction grating. I think, alright, this we have shown. We have shown this, no, in diffraction you have to know. We have also given a diffraction grating. Okay, and so along with we have given a CD also and a diffraction grating also we have given. Children can see the difference between them and say now what you get with a CD and what you get with a diffraction grating. And next time we go about, we only have a sheet for electron diffraction, explaining, I will say, the wavelength of matter, wavelength of electrons, and then the kind of diffraction pattern you did. So when you obviously pass electrons through a metal crystal. So I will say that's what it is. And here you can see this particular are electrons waves too. So I will say, since we cannot have any activity, because actually the picture, the schematic diagram of the experiment and then the results which are given here. And here I will say that actually historically how it all developed, that has been fine. Now after this I will say now by Schrödinger I will say developed this wave mechanics before considering the wave nature of matter. So he considered the states of any particle in which it can exist. So this individually we call wave function. We are not using the wave function in this particular kit because I told you that the kit is only up to I will say now secondary level. And then I will say now here I will say now this is where body also it was shown to say, and then this is the interesting thought experiment by Schrödinger called Schrödinger's cat. Say, this is the cat inside, and here there is some radioactive material there. It so happens that when the radioactive atom decays, it triggers one bottle which contains poison. The cat is supposed to consume it and it is supposed to die. But only the point is that until I will say you look into the box, you don't know whether the cat is dead or alive. So these are the two states in which the cat can exist simultaneously. Until when? Until you open the box. So now these are the two states. So now a particular state, I'll say that I suppose Schrödinger considered. So it could be particles can be in several states, but it can have a different amplitudes. And then, but then what happens is that the particular, I will say now, cat can be in many other states also. It may be a smiling cat, maybe a meowing cat, maybe I will say now sleeping cat, it may be anything. So that you can consider several states of the cat. But we are considering only the two states here. Okay. So this is just to give an example. So now particularly the particle in quantum mechanics now can exist in a number of states. So, and here there are we show only the two states, but then it can have many other states also you can think of. Yeah.
So we have a flip card which shows both the states. So it's just a concept which we are showing through a simple flip card.
Okay, it's really, I will say, nice. I will say, you can just flip it like this slightly. Then once you will see the cat alive, this time you see it dead. Now, I will say now quantum tunneling is something morning also, so we had talked about it. It's perhaps one of the most important effects of quantum mechanics. And we know that if there is a barrier and a particle is particle cannot also overcome it unless it has sufficient energy. But then quantum mechanically it can possibly tunnel through it
And so because the wave function which is existing on the left side, some the wave function can also exist on the right side. That means it can have a possibility of being on the right side. So that is a very slow answer. So there is a small activity which has been really developed. It's in fact it's in form of a game for some small kids. I think we won't take more time. We won't not more time. Yeah. So I mean, so now next idea is say now now this is the quantum tunneling. There's a small activity here, and so that a person there is a cutout there, some hole, and you throw some marbles. Sometimes in the quantum the kind of energy is around, you cannot really overcome, but it can tunnel through it sometimes. Okay. So that's what it is. And then the importance of tunneling is given say several other things also. Like say how do we make energy from the sun? So now whenever fusion reaction takes place between deuteron and neutron, they have the Coulomb energy. They have to overcome this Coulomb force. And unless the quantum tunneling happens, they cannot really combine and produce a helium and proton and neutron and then energy. So now that is where also quantum tunneling is so important. And let me also tell you that this year's Nobel Prize has been given for quantum tunneling, but for larger microscopic systems. So I will not delve into it. But now this is some of the particular slide which are really using playing some of the activities. And next thing is very close to say now quantum entanglement. We do really we have explained quantum entanglement in the activity on this function waves. But here is something that's now it's an interesting activity which has been developed for quantum entanglement. I think Kathan will show it within a short period.
So there is a small card which is for the entanglement that
so okay, so
in the box there, all the activities have been recorded in video formats also, which will be shared by GUJCOST. So what we have done is basically we have two small boxes through which a child can observe the entangled particles. So we have a small sticker which a child can stick along a stick on both the sides, and they can try to flip the side of the stick on one side. So if one child is flipping the sticker, the other child on the other side would also see the flip particle. So this is how we are trying to explain the concept of quantum entanglement through a simple toy or a game. So that is how we are trying to do that.
And there's some applications of quantum mechanics. So this has some activities, now, which have been given in the form of information sheets, like say X-rays or say CT scan or now the solar panels, there's a photoelectric effect, there's an electron microscope, and also how lasers are produced. Okay, there are activities even also how lasers can be produced, but then that is in the case of laser, the more atoms have to be in the higher, that is the excited state, and suddenly they all have to come down, so that many atoms, a large number of atoms, they produce energy which are in coherence, and then a very powerful the light comes out. So for that there is a very simple activity which has been given, but then this is basically the idea. And here there is a photocell given. Here is a photocell, and you put it in the light and exposed to light, and then it can light an LED. So connected to LED, and then the moment if you put a hand on your cover the photocell, then now the LED switches off. Then there is another interesting activity of photoconductivity. Photoconductivity essentially means that the electrons are not knocked out, but they are only now excited to the conduction band, and they become available for the electrical current. So now now this is
really an interesting activity. But say, I don't know whether I say, what would you explain?
I think it would be very difficult to see from a distance, but basically this activity has a breadboard. On the breadboard we have made a circuit connection of an LDR and an LED. So if I cover the LDR, it's going to dim the LED light. But if I shine more light onto the LDR, then it is going to glow the LED more. So this is how we are showing this particular activity of photoconductivity.
I don't know whether you are able to see it from a long distance, but then this kit which has been given to you, so now you have to, I assure you that every activity, every experiment works. Okay, so that's one thing. So next thing, similarly, so now for the nuclear fission and fusion, so there are a few activities which children can do with their hands. You will wonder, so what are these activities? Certainly, you cannot say make fusion and fission by hand, giving them some parallel something like that. But then here is something, say, using this paper, we also had limitations with the kit, How much can you do and what can you do? And also its size of the kit and the price of the kit. Okay, we had those limitations. So accordingly the activities were developed. I think say can go ahead with that. So this is what it is. This is what shows the nuclear fission chain reaction, and here also this chain reaction, and here is one activity for this nuclear fusion. Now next coming to computer computing and the future, there have been a few activities, not many, but there are a few activities here, and essentially, so now here when you talk about computer computing, etc., I'd say there have it's more conceptual at this level or more theoretical at this level. So which means that it's not really possible to give activities per se in the kit. So now there are a few activities which are given either in the form of a sheet, information sheet, or some sort of analogies which have been given. And that is how this particular activity classical and quantum computers. Similarly, say the difference between quantum computers and classical computers, and there is what are now this year, how quantum computer looks like. This is a Google computer which has been recently made, recently announced that, and then here is an activity by which it can make a small, of course, static model of a quantum computer. If you make it follow these instructions, then this is the kind of thing you can make, and this is what it shows. That's what a quantum computer looks like, which is given here. Well, this is what it is in the school, and again, it's a quantum teleportation. This is a beautiful thing. I take some time to explain it now, but then I think that you would read it. You can read it. I want to save some time because I think Dr. Sahu will looking at me asking me to complete as early as possible. So he's waving at me. So I think I'm not going to explain to you in detail. But then this is again a comic strip, and now this explains how quantum teleportation takes place. I have a photon, and then I'm here on the Earth, and my friend is on Mars, is me. So now I want to save some information for him. I have a photon, and then now which I want to send, that's the information I want to send to my friend on Mars. So now, and then now what happens, I take two correlated photons. One comes to me, one goes to him. I have to do now when at my end these photons interact. Now similarly, now photon will change to some different color or whatever it is. How can that change on Mars? I will have to send again now some information I have to send. Say for example, maybe 2 qubits I have to send to my friend on Mars, and then he can do the mathematical operations, and then the photon which I wanted to send to him, his photon also will turn into that. So that is how the information will be communicated. I will not tell you in this detail. I don't know whether I will able to convey to you in say half a minute. But and then there are some informative charts which are really interesting. Now you can see that this is about mostly about this some shop basically the sensor ideas, some ideas of quantum mechanics. What is this about? Okay. Now and this chart talks about methods of quantum science and technology. So these are about 33 activities. Now I must tell you that so some of the activities we need to include here, say which we shall include in the next edition. For example, one important activity which we would like to include is the uncertainty principle. We did not include it because I will say now at the 10th level, say the children really cannot really and neither they can understand nor they can appreciate about this particular thing. Only when they did 12th standard or maybe college level, so they will be able to appreciate it. In addition, so now these are some of the activities which we would like to include in the next edition. Say about more about this quantum mechanics, quantum computing, sensing and methodology, materials, devices, on which now the work is being done. Well, I can explain to you, I can tell you which activities or what kind of things we want to develop, but I will refrain from that. So now I can say this is all basically that only when you use this text, one activity by another activity, read it, you will be able to appreciate the text. And I hope I will say now you would like it. Please do convey to us if there are any mistakes which are printed. I do know there are a few printing mistakes which are printed. And you can also suggest the ways to improve those activities and also tell us which more activities we can include in the next edition. Okay, I think with this I shall stop. Thank you.
Thank you, Dr. Kambli and Mr. Kothari, for making quantum concepts tangible and accessible. Now I would like to invite Dr. Narottam Sahu, advisor GUJCOST, to felicitate Dr. V.V. Kambli, former director, Vigyan Prasad.
जल्दी
Thank you, sir.
Thank you. We have to like to thank Dr. Kambli sir for his mission, lifelong mission for taking science to the people and people to the science. So with this session we are concluding today's activity and discussion and panel program for this first day. Now we will be moving, requesting all the participants to be there at in our quantum lawn